Welcome to this course on Python. In this course, you are going to learn a lot about Python, the programming language, and how this programming language can solve different problems in society and in the corporate world. To begin with, in the very first module, you are going to understand why you need to learn Python and how we are using Python for solving different problems. So I'll start with a simple concept, artificial intelligence. Because today, take any application in AI. We talk about Alexa, we talk about Siri, we talk about so many assistants that we have. Here, everywhere, we are using Python as a programming language to develop these models. So, first let's start with artificial intelligence. What is AI? AI is a scientific concept to create intelligence in machines. How can we replicate the human intelligence into a machine? That's what we try to understand in the name of AI. The concept of AI is all about analyzing data, seeing some patterns out of it, deriving intelligence out of it, and then that intelligence, how it can be fed into a machine so that the machines can take some independent decisions and intelligent ones. In fact, when we talk about artificial intelligence, analytics and data science is something that we cannot ignore. We connect analytics and artificial intelligence because AI is nothing but deriving intelligence, and the intelligence comes from the data. And how do you connect data and intelligence? It's nothing but deriving insights with the help of analytics. So from data, you use analytical tools and techniques to derive insights. Then where is data science coming into picture? Data science is the process of analyzing data with the help of statistical techniques. So now what we are trying to do here is, we are trying to do AI models, build AI models with machine learning concepts where we bring in the power of statistics, data science and analytics. And we need a programming language to connect all of them and build beautiful models. And this is exactly where Python is coming in. You need a programming language like Python to develop such models, to develop such solutions which can solve problems in the corporate and in the society. Now, having said that, you need to understand the different areas of AI and how Python can pitch in across different areas of artificial intelligence. When I say AI, there are broadly 5-6 areas which are very popular. The first one being machine learning. What is machine learning? In simple terms, it's predictive analytics. So deriving patterns from the past data and using those patterns to predict the future. Can I use Python to develop models which can derive patterns from the past and which can help me to predict the future? Definitely yes. So Python is the most popular language for you to use to build such machine learning models. The second area of artificial intelligence is computer vision, which in simple terms we call it as image or video analytics. That is, I can analyze the images pixel by pixel. I can find and understand what is there in that image, and I can use Python kind of programming languages with extensive libraries that are available there, which can help me to understand the images and the videos in a better way. So computer vision, when you think of solving problems using CV, then Python is a choice for you. The third area of artificial intelligence is natural language processing. I'm sure you have heard of this because every voice assistant that we use, Alexa, Siri, OK Google, all these belong to this concept of NLP, natural language processing. Today, most of the NLP models, the large language models that we talk about, are all built using Python as a programming language. Again, without Python, we can't think much about NLP as a concept. The fourth area of artificial intelligence, which is a subset of machine learning, I would say, is deep learning or generative AI. So deep learning and generative AI, I'm putting together in one bucket because all these generative AI models that we're talking about in today's context, like ChatGPT, like DALL-E, all these models are built with the help of machine learning, with the help of deep learning, with the help of statistics, of course, coded in Python. So Python forms a strong foundation for building AI, machine learning, computer vision, NLP models, which are actually solving most of the problems in the AI world today. I hope you understood why we use Python, where we use it, and how it is getting extensively applied in the field of artificial intelligence. Let's understand more about this in the upcoming sessions. Welcome back. In the last session, we discussed about artificial intelligence and different areas explored in the space of artificial intelligence. We understood how Python can help us in building some models in machine learning, computer vision, NLP. We are just discussing that Python can play a significant role and it can contribute to solving some problems in the corporate and in the society. Now, in this session, we are going to understand whether Python is the only programming language or is there any other programming language that can help us to solve some problems using AI. I'll start with Python, the most popular programming language available for AI. I think that is the reason you are taking this course. Python is the leader with around 60 to 70% of the data scientists and machine learning developers using it. Almost other than AI and machine learning and data science, people also use it for a lot of other developments. Scripting and other places, you will find Python as a natural tool for development. Why it is a market leader? It is a market leader for primarily two reasons, I would say. One, the focus is more on the code, the focus is more on the algorithm and not on the syntax. Python syntax is very easy for you to pick up. It is like learning simple English. The second important reason, which is what is making Python more popular, is the availability of libraries. The open source community is contributing heavily to use Python as a programming language, and anything and everything that they have developed is actually solving problems for you, and they are reusable components for you to use and adopt in your solutions. I'll talk about Python more in the upcoming modules. Moving on, I'll move to the second most popular programming language in the space of AI, R. Usually R is seen as the academician's paradise or statistician's paradise. The reason? While Python is acting more like a kind of a machine learning developer's friend, that is, usually the computer science professionals, the programmers or engineers are pretty much comfortable with Python as a language to code. And R is usually adopted by statisticians, academicians, because it gives them more liberty to play around. So R is a graphic-based language tool used for statistical computing, analysis and visualizations in machine learning. If you want to explore statistical data via graph, this is the best platform. It is also used for a variety of purposes, I would say, by data scientists at Facebook, Google, and many other technological giants. A very popular programming language, as I mentioned, for statisticians, and this is also applied to machine learning tasks such as regression, classification, decision tree formulations. The third programming language that we are going to discuss is Java. So Java has been popular for a long time. When I completed engineering and when I started getting into the corporate world as a Java developer, this was the first language I started learning. It is also, even though it is popular for the web app development and other things, it is also used for developing applications in the space of AI and data science. 15% of the experts are using this particular language for network security, cyber attacks, fraud detection, where Python may not be of great help. So I would say Java still has a role to play when it comes to such kind of programming applications. And it's an easy to use language for several reasons. One, simple debugging process. Second, huge package services that are available which you can inherit and implement. Three, the work can be simplified when you're working on a large project. Four, you can represent the data in a graphical format. Five, I would say better user interaction. When you're using Java, it is easy for you to interact with the users. And last but not least, it's a secure language. That's why cyber security applications, if you're going to develop, Java can be a preferred one. The fourth programming language is JavaScript. JavaScript, again, more associated with Java, is most widely used language to improve web development. So anyone who is new to data science, machine learning, they generally prefer JavaScript to begin with for enterprise focused applications. So if you're starting from the scratch for an enterprise, maybe JavaScript can be a good beginning. It's easy to pick up. There is also one more language which we can use in AI machine learning context, that is Scala. Scala is one of the core platforms that has been developed by Apache Spark platform, a comprehensible data platform that is used for multiple functionalities, for big data processing, for machine learning statistical algorithms, which has a huge library on its own, the machine learning libraries of its own. So Scala helps you there. So this language provides programmers to develop, design, code, deploy machine learning algorithms by making the best use of the capabilities with the help of big data technologies. So I would say, even though we have discussed 5 different programming languages, I would still say Python is the best. If you are starting your career, if you want to pick up a new programming language which will open up a lot of opportunities for you, Python is the best. And Python can be used for a variety of purposes like web application development, data analysis, data science, statistical algorithms implementation, machine learning, artificial intelligence. It has so many variety of purposes. So Python is a preferred choice for most of the programmers. Even data scientists, even data engineers would love to use Python. And newbies to experienced IT developers, talk to a 15-year experienced person in the market or talk to a fresher. If you ask them what is a programming language that they have picked up, usually the answer is Python. In fact, 20 years back when I was in engineering, we used to start with C, C++ as the programming language. Today, every one of the engineers are trying to pick up Python as a programming language, considering its wide variety of purposes. Consider the visualization tools also available with Python, which is helping engineers to understand how data can be visualized, analyzed, and the interesting relationships can be found out with the data. So I hope you have understood the importance of Python as a programming language. Even though we have many options, Python is the best when it comes to all these examples and applications. So in the next session, I'll explain to you what makes Python distinctive. What are the features of Python? Let's slowly get into the Python world with our next session. Thank you. Welcome back. In this session, we are going to understand what is Python. What are the features of Python that makes Python a distinctive language for programmers? To begin with, can you guess when Python was created? It was in the year 1989. That's when the Python was created. And guess who has created that? It was created by Guido van Rossum. In fact, he was inspired by his favorite show, which was created by Monty Python. That's how the name Python came into picture. It's a very general, high-purpose, high-level interpreted language with easy syntax and dynamic semantics. That's what makes Python different from other languages. Of course, it is open source. You don't need a license to use this particular language. It's a large standard library. The huge set of libraries that are created by other open source communities are helping Python to be different. It follows the hoops concepts. As I mentioned earlier, object-oriented programming concepts are well established and well utilized in this particular programming language. And of course, it is easy to learn. If you look at the features of Python, I would say the first important feature is simplicity. This Python language is designed in such a way that you think more about the code than about the syntax. Unlike other programming languages where syntax is more important, you need to pick up syntax. If your syntax is wrong, you will get compiler errors. Here that is not the case. Here the focus is more on your thinking process, your algorithmic logical structure thinking. The focus should be on that and not on the coding syntax. That's what makes this language simple. Now moving on to the second feature. The second important feature of Python is it is open source, as I mentioned, which means it is free for everyone. And this is what is making corporates look into Python as a potential language. And they are very much excited about this because unlike other programs, other platforms or the tools which comes with a huge license cost, this language is actually free of cost. So they don't need to pay to get this programming language. All they need is hire good Python developers who can develop models from the scratch. So that makes it attractive. The third important feature is portability. What is portability? You can write code in one computer and then you can take it across to another computer without much hassles. So Python code also can be written in any computer and it can be deployed and used in any other computer. Actually, this makes code sharing very, very easy. So programmers love it. Unlike some of the other languages where you need to store it in one place and porting it into another computer becomes a challenge. Here that is not the case. So Python offers that as a quick feature. The fourth feature is this language is embeddable and extensible. Python allows code of other programming languages like C, C++, all these programming languages, the code written in these languages can be embedded into it so that you can perform certain functions on that code. So in a way, this is like the huge ocean where any river can join. So any programming language can be embedded, any code that has been written in a legacy application can be embedded into Python, and you'll be able to play around with that code also with the help of the libraries, which makes Python even more powerful. This feature is not available with many other programming languages. So Python is definitely distinctive there. Python can be easily interpreted. The task of CPU and the memory management, which is a challenge with some of the programming languages, is not a problem with Python. It is handled completely by the Python itself. So you as a programmer need not worry about how much would be the processing power that is needed for executing this, how much would that memory be needed for this particular execution. You need not worry about it as a problem. So that makes Python again a friend to the programmers. As I mentioned earlier, Python has huge libraries. The diverse libraries that are available with Python are actually the reusable assets which programmers can use to solve different problems. You need not reinvent the wheel from the scratch. If somebody has solved the problem already, it is available as a library. You just need to import that library in Python and start reusing the code. So it has huge set of libraries even for data manipulation, data adjustment, data analysis, data visualization. Like I would say NumPy is there, Matplotlib is there, Seaborn is there, scikit-learn are there. So in fact, there are so many libraries which are very popular, which makes Python also equally popular. And Python follows OOPS concept. So obviously you can break down a complex problem into smaller set of problems, and the code also can be written for each and every smaller problem, and it can provide security to it so that you can get better solutions. So OOPS concept promises that, and since Python follows OOPS concept, you're able to get the benefits of all the OOPS in this particular programming language. So to summarize, Python is free source, Python is easy to learn, Python allows embedding of other code written in different programming languages, Python allows libraries which is helping you to use reusable assets, Python allows object-oriented concepts and Python code is portable. Doesn't it sound exciting for you? When Python has so many good features, this automatically makes Python a very powerful programming language in the market today. I hope you have understood the benefits of Python. In the next session, we will understand where to code, how to code, and we'll slowly get into the programming side of things. See you in the next session. Thank you. In the last three topics, we understood how Python is fitting into the corporate world. We also understood how Python is a very powerful language for programmers. Without spending much time, today we are going to learn how we can start coding in Python. But of course, to begin with, you need to set up an environment. There are broadly two approaches that people follow when it comes to setting up the environments. First approach is setting up Anaconda, setting up Python in that so that you can start coding everything in your own personal laptop. This is one way of doing it. The second way is you can use online tools, online Python engines, which can be very powerful, which can give you more computational power because those platforms are sitting on cloud. Considering you are just starting your journey, while you're going to learn more and more models, which needs more and more computational power, I believe that you should start using the online platforms. So in today's session, we are going to take one particular platform like this, what is popularly known as Google Colabs. So just go to Google. I'm going to show you how you can access this and how you can start accessing Google Colab to start coding. Go to Google, type for Google Colab. When you search for it, you will get a result like this, Google Colab and welcome to Collaboratory. I'm just going to click welcome to Collaboratory so that you understand what can be done with the help of this particular platform. Google Colab is an initiative by Google to help programmers write, execute piece of code in Python in the online world using their powerful CPU and GPU clusters. If you notice here, Colab allows you to write and execute Python directly in your browsers. You don't need a separate software to be installed in your laptop. Zero configuration required. Access to GPUs, which are much needed when you are looking for deep learning models where you need more and more computational power. This particular platform can provide that free of cost. And you can easily share these notebooks with everyone. Remember, I told you about portability, one of the important features of Python. This platform helps you to port your code in the form of Jupyter notebooks from one system to the other. Now, how do you get started here? So now look at the screen. You have multiple tabs that are available here. I'll start with a simple one. Go to File and press New Notebook. Notebook is nothing but pieces of code that you can write for a specific context. Of course, I've got a message now. When I clicked on New Notebook, it is asking me to log in into Google account. Let me sign in there. So to access Google Colab, you need to log in with your Gmail ID. Please use your personal Gmail ID and log in. And once you log in, you'll be able to see your name on the right top. And post that, you can go to File and create New Notebook. When you click this New Notebook, you get to see this particular window. It comes out as untitled 0.ipynb. The .ipynb is an indication that what you are doing is a Python notebook. Now I can rename this. I will just put it across like test. So all I'm doing is I have created a new notebook and I've just renamed it to test. Here you can see there are two buttons here, plus code and plus text. Plus code is nothing but you can insert coding line in this notebook. Plus text is you can add a text cell. If you want to write any comments for your code, if you want to explain what you are going to do, you can use the text cell to write anything you want. Let me start with the text cell. I can say that this is a test notebook created for this course. And if I press Ctrl Enter, this is done. I have completed it. Now I can write a piece of code here. I have created plus code. Let me click that. And I can create a piece of code here. It can be anything. I can even write a comment of the code in this particular line, or any pieces of code I want to write, I can write it here. So let me start with a very simple assignment operator just to help you understand how this works. X equal to 10. And I just want to print X. Now you see a play button on the left side. This play button, if you click it, this particular code gets executed. The shortcut for this is Ctrl Enter. The moment you write your lines of code, you can just press Ctrl Enter and the code will be executed. So let me try executing the code now. Now this shows that the code is in progress. Now the code is executed, the output is shown across. So what I've done is I've just assigned the value of 10 to a variable X, and I just printed X just by typing X in the cell. And I've got the value of 10 as an output to show that X carries the value of 10. I hope this particular environment is very comfortable for you to code. We are going to use this particular notebook, and for every concept that we are learning, we are going to create new notebooks. And as part of this course, I'll also be providing you these notebooks so that you can execute and you can try things on your own. And in every session, every topic that we are going to cover in the upcoming days, I am going to teach you how you can use this particular environment of Google Colabs, how you can write new lines of code, and how you can create new projects with the help of all these concepts. So just play around now, get comfortable with Google Colab, understand more about this environment, while we connect again in the next session, in the next topic, to understand how Python works. Thank you. Welcome back. As we get to the coding side of Python, it is important for us to understand the foundational blocks. Variables and data types are the foundational blocks of Python. In this section, we are going to understand more about what variables are and how these variables are generally named. We'll also understand about the different data types that exist in Python, ranging from numeric, then strings, then how do we address Boolean types. At the end, we are also going to learn about how to cast the data types. We'll look at some examples and we will do everything hands-on as we progress. So, time for us to get to the topics. Welcome back. In this topic, we are going to understand the variables. What are variables? Variables are reserved memory locations for storing values. I'm sure if you had learned any other programming language, you would understand what a variable is. We define variables like X, Y, Z, A, B, C, and we store values to it. So Python does not use explicit declaration of the variables. That is, you need not define and then get onto the code. If you had known any other programming language, you would have noticed that we generally declare the variable first, calling it out with the data type and say that this is the variable of this data type, and then we start assignment to it. But here, Python does not need that. If you remember, I told you the feature of Python is it's more about coding than about syntax. So here, you don't have the syntax to explicitly declare variables. You can directly start assigning the values, and based on the value that you are assigning, it's going to take up the data type. So the data type of the variable is defined by the type of value assigned to it. If you assign number, it's going to take it as number. If you're going to assign a string, the variable data type is going to be a string. So the multiple assignment can be done in the same line. So in the same line of code, you can put x equal to 3, y equal to this particular string. You can do more in the same line of code which Python permits. And variables can be deleted using a very simple instruction, that is del variable name. If you say del x, the variable is deleted. So simple, isn't it? So this is how the variables are generally defined. But while we talk about variables, it is important how the variables are named. When we work in the projects, this is something which talks a lot about our coding standards and the way we have professionally learned the programming language. So how do we name the variables? First of all, variables cannot start with the numbers. Second, it can only contain alphanumeric characters and underscore character. Like you can say that variable string underscore name. If you're going to store a city name into a variable, you can say that variable city underscore name or variable person underscore name. You can call it this way and you can define it. And variable names are case sensitive. Case sensitive means capital versus non-capital. It's going to differentiate very, very clearly. The names should start with a letter or an underscore. That is something which is very, very important. So these are some basic conventions that you should follow when you are naming the variable. Now, in the next topic, you are going to understand what are the different variable types. And once you learn that, we will directly jump on to the hands-on exercises and we will try it out, how the variables are defined and how the variable data types can be fixed. Are you ready for the next topic? See you there. Welcome back. In the last session we discussed about what variables are. Now it is time for you to understand what data types are. Data types, just like variables, are very much essential for you to tell Python what kind of data is going to be stored in those variables, in those memory locations. Accordingly, the memory will be allocated and you will have the freedom to use that memory. In fact, Python is intelligent enough and simple enough as it can process the memory on your behalf. As I told you, Python has the memory management as an inbuilt feature and you need not explicitly declare how much memory you would need based on the variable. Now, shall we understand what data types are? So if you look at the data types, there are multiple data types that exist. In simple terms, data type is nothing but the type of variable that you are going to use, the type of data that you are going to store in those variables. It can be numeric. When I say numeric, it can be integer, it can be a complex number, it can be a float. Same way, dictionary, boolean, set, sequence type. These are all the different data types that exist. In fact, I'll just talk about the types alone here, like integer, complex number, float, dictionary, boolean, set. These things I'll talk about because we are going to discuss in detail in the upcoming sessions on what the sequences are. So we'll be understanding more about the list, tuples, sets, and all those other aspects which are covered under the data structures format, because it's slightly complicated compared to the data types, what we are discussing now. Now let me deep dive and explain to you the numeric data type. There are three different types of numeric data types which you have seen. You have integer, we call this as signed integers. You have float and you have complex variables. Complex, I'm sure, right from the school days we have been learning that. X plus yj or x plus ij used to be the complex form, if you remember. So this is how we have complex variables. You have integer and the float, the other two data types which comes under the numeric format. Integer means simple number like 5. Float means 5.5. I'm adding a decimal to it. And when I say complex, it is a plus ib or b plus ic or 3 plus 4 I. Like that we have complex numbers. So these three data types can help us store multiple different formats of complex data. I hope you have understood what numeric data type is all about. Now let's understand the other simple data type called as strings. Strings can be used to store anything that is character in nature, an array of characters, a group of characters, like a name for example. If I say Lakshmi Narayanan, it has a group of characters in it. I can take these characters and I can put it in the form of a string. So the string data type variables can be assigned by using quotation marks. So I have to put the name, that is Lakshmi Narayanan, within quotation, and then I have to assign it to the string. And you can call the variable name like person name, tutor name. And as I told you in the variable notation, how are you going to store the variable? You can call that variable as tutor underscore name or the program underscore tutor. Like this, you can define the variable and then you can assign this particular string as part of this variable. For example, another example, I would say my underscore car is a Toyota car. So I can put it like my underscore car is equal to my car is Toyota. So this Toyota is nothing but the string of characters which have been saved together and you are calling it as a string. Basically, the way it is stored in Python is the strings are considered to be arrays. You are calling it as arrays of characters. Have you heard of arrays before? Arrays are nothing but you can store multiple number of values in one particular variable type. That's what array is all about. And Python does not have a character data type, unlike other programming languages. In other programming languages, you would have seen char, that is char, as a character data type and string as a separate data type. But in Python, we are merging both and we are calling it as only one data type, that's called string. So even the characters can be stored in the string data type. A single character is simply a string with length 1. That is, if I say alphabet A or B or C or hashtag, all these are characters. And I can store these characters in a string. And all I would look at is this particular string is of length 1. If the length is 1, you call that as character. Multi-line strings are usually represented within the quotes so that Python knows where it starts and where it ends. If you leave a space in the beginning, let's say for example, space and then Lakshmi and within quotations, Python will store it like space Lakshmi. Or if I write the name like within quotations, I write that Lakshmi space Narayanan. It is going to look at it as one string where space is also considered to be one of the characters in the string name. So this is how Python looks at strings. Now, having understood strings, it is important for you to understand what kind of operations we can perform on strings. What we generally call it as slicing and accessing strings. Let's go back to that example. My car, the variable name that we declared. My underscore car is equal to my car is Toyota. My car is Toyota is the string that you have stored in the variable name my underscore car. Now, what are the different operations I can perform? I told you this whole string is nothing but character array of characters that are stored there. If I say my underscore car and then 0 in the box, it says that I want to fetch the first character in this particular string. So what is the first character here? It is M. Since I said my car is Toyota, M is the first character. I'm just taking that M as the first character and returning the value here. So when I use these values, the way the string is stored, it's an array of characters. It's going to pick up that particular character based on the count and it's going to return that number. This is how the character operations or the string operations are performed. If I take my underscore car 3:6, can you guess what this would return? Yes, you guessed it right. 3:6 means it's going to start from the third character and to the sixth character. So whatever that lies in between, it's going to return. Let's look at the response. It says car. Why is it car? Why not the space? Because the third character is space here, isn't it? My space car. That's how the string is stored. Then why are we not looking at it? If you notice, the character length starts from 0 and not 1. That's the reason in the first one when I said my underscore car of 0, that denotes the first character. Now when I say the third character, 0, 1, 2, 3 characters are gone and then I'm looking at the third character. That's why car, C, it starts from C and the reason the car is returned. I hope you're able to understand the difference and you're able to decode where the beginning of the array is. Let's take one more example. My underscore car, I'm saying 3: without an end character. So what does it mean? If we don't have the end character, how is Python going to understand this and give you a result? Did you guess it? What could be the possible result? Yes, you are right. The result is, it starts from the third character and since we don't have the end character, it goes up to the end of the string. Like for example, here car is Toyota. The complete string is returned right from the beginning of the third character. The fourth one, if you notice, I can say I can concatenate strings just by using the plus button. The plus is a kind of an operator which you'll be learning in the next section. It can be used for addition as well as concatenation of strings. So here, when I say my underscore car, this is a string variable, a variable of string data type, and you are concatenating it with another string. Like here, for example, I'm saying Supra. So what do you think the value will be? The answer will be, my car is Toyota Supra. I hope you're able to understand. It has taken the complete string and it has added that new string, that is Supra, to the particular string and stored again in a new variable or in the existing variable. This is how the string operations can be performed. Where do you think you may need this? A practical example can you think of? Let's say you are working in an Excel sheet kind of data set. I have the name of all the students or all the employees in one particular table. Now, your marketing team wants to run a campaign and they say that instead of the full name, I just want to use the first name for running a campaign. Is there a way that you can identify only the first name? Can you think of using this set of operations for performing that? If you're able to connect the dots, that means you have understood this concept. I can use these kind of operations to clearly identify where to start, where to end, how to pull up a substring from a string. In fact, the regular expressions which we are going to learn later will also help you out to do the same operation. But that is for another day. So you have understood how to slice and access substrings from a string, which is array of characters. So we have understood two different data types so far, numeric and string. Now it is time for us to look into the third one, Boolean data type. Boolean data type has only true values, that is either true or false as the name indicates. Any if condition or any comparison you would like to make can only carry these two values, true or false. If A is greater than B, what do you think the value would be returned? The value would be true or false depending on A and B values. This is what we call it as the Boolean type variables. Bool, B-O-O-L, and then parenthesis can be run on any other value to get one of these two results. So the bool can return either true or false. Let's look at some example here. So the bool returns true for any integer, string, or even the list types. Remember, this is how it can be used across. It returns for empty list the integer 0 or an empty string, that is for the empty list. A function can also return a Boolean value. So you need to be aware of all these things. Now it is time for us to explore all these aspects, the three data types that you have learned, that is integer, float, and the complex as part of the numeric data type. And then we also learned the string operations, the string data type, and the Boolean data type. Can we try all these things hands-on in our Jupyter notebook? So in the next topic, we are going to do this hands-on in our Python notebook. Remember, in the last section, in the last topic, you installed Google Colabs. Now it is time for us to access that, use that, and start coding. Are you excited? I am excited. So see you in the next topic. Welcome back. In the last topic, we discussed about data types, three different data types. Now it is time for us to do hands-on in our Google Colab. If you remember, in the last topic, I was telling you how you can use Google Colab. Go to Google Colab and create a new notebook. When you open a new notebook, you can rename it as variables and data types. Because here in this notebook, we are going to try both variables and data types. Now let's get on to hands-on. As you can see on the screen, as I was telling you earlier, I was telling you that Python has this beautiful feature where you need not declare the data type and the variable before starting to use it. So here I am trying to assign value 3 to the variable a. So 3 is an integer. So automatically the variable a carries the data type integer when I assign 3 to it. Now let's try it. I am trying to type a is equal to 3 and type of a. The type of a is nothing but it is trying to understand what is the data type of this variable a. Let's execute this and check this out. As you can see, the type of a has come out as int, which is an indication that it is an integer data type. Same way, let's move on to float. 3 and 3.0, what is the difference? 3 means integer, 3.0 is a float variable. Now I'm assigning 3.0 to a variable b and I'm checking what is the data type. Type and execute this. You'll be able to see the type of b which has come out to be float. I hope you're able to understand. Just by assigning the value to variables, the data types of the variables are assigned automatically by Python, which makes a big difference compared to other programming languages. Now let's assign strings, the third data type that we understood. This feels amazing. I'm just typing it, and as I mentioned, should be within quotes when you are talking about strings as a data type. So when you are typing this feels amazing within quotes and then assign it to variable c, you are getting the type of c as a string. str denotes string. In fact, I can also create multi-line string assignment. That is, I can have a whole paragraph, or it can be with a kind of a new line character within the string, and I can still assign it to the string variable. Like d equal to, I'm saying this is a new sentence which is multi-line. Now when I execute this, what do you think the d will have? Let's check that out. it has just printed the text as we have assigned it. That's the reason we are using triple quotes. Triple quote is an indication that it's a multi-line string. If you have a paragraph or if you have a huge text corpus which you would like to assign it to a variable, this is the way for you to do it. Remember, string stores everything as array of characters, including the new line character, including the space. That's how this works. Now let's work on the strings. Remember, we discussed about splitting the strings, slicing and dicing, and check out what is there in the string. We are going to execute that and see. I'm just taking a simple string variable. I'm calling it as my_str. Look at the naming convention, the one I explained in the last topic. I'm using my_str. Two words, I'm including them or I'm concatenating them with the help of the underscore character. My_str is equal to hello world within quotes. So hello world is a single line string. I'm assigning it to my_str. When I execute this, my_str of 0 means it denotes the first character. My_str 0:5 denotes the characters from 0 till 5. Now let's check out how the values have returned. My_str 0 has returned the first character H. My_str 0 to 5, 0:5 indicates the first 5 characters HELLO. And my_str plus I am here is helping me to do a string concatenation. It is adding two strings. Now hello world, I am here. You're able to see that? Now let me make a small modification. I told you that I can include spaces and make it look like separate one. As you can see here, hello world, I am here. World and I are coming out as one string. Is there a way I can give a space? Because that will explain the sentence in a better way, isn't it? Now let me execute that and see. Do you see a space here? Just by adding a space in the text, I'm able to bring the space in the output also, what is stored in the variable. So this explains what I can do with string data type. Now let's move on to the next one, the Boolean type. I told you earlier, Boolean type can be true or false. These are the two values it can carry basis the operations that you have performed on the variables. So I want to define whether a number is even or not. So this is more like a function. What is a function? We'll be learning it down the lane. Don't worry about it. So I'm defining a function where I'm passing a number as an input. Now I want to check whether this number is even or not. Even means when you are dividing it by 2, the remainder is 0. If it is not even, the remainder will be 1. Depending on that, you want to call it out as even or not. So here I am using if num %2. What is a percentage? This is a modulus operator you will be learning in the next section. For now, you assume that it's going to give me the remainder. If num %2 equal to 0, that is, it's an assignment operator. If the remainder is 0, then return true. That means it's an even. If not, return false. Now I have written a code. I am passing the number 3 to this function, even or not, and I am assigning the outcome to a variable e. Now what is the data type of this variable? Make a guess. We are assigning the outcome of this into a variable e. That means the variable e is going to be Boolean, since I am returning true or false as an output of this function. Now let's print e and let's check out the type e. Let's see whether our assumptions are right, whether our answers are right. Absolutely right. So when I print e, number 3 is not even, so it has returned false. And the false is a Boolean type. As I mentioned, Boolean type means it comes out as BOOL. So I hope you have understood how the Boolean type works. Now let me also play around with the Boolean type and help you understand in a much better way. Print bool of 1. It returns true for all integers and strings, bool of string and bool of just quotes. returns false for empty strings. If you remember, these are the three things that we discussed when we discussed about the Boolean types. Let me just execute this and check the outcome. Bool of 1 will always give me true because it's for all integers and string. Bool of string also is going to give me 1 true, as I explained earlier. Bool of empty will return false. So everything is working as expected, isn't it? Whatever we learned in the last topic, we are able to do it practically and so on. Now, when we discussed about variables, we also discussed about multiple assignments to the variables. Let's look at some examples here so that you understand how multiple assignments can happen using Python. I am taking A1, A2 and I am assigning 2 and 3 as values. But look at the way I have assigned it in Python. A1, A2 is equal to 2, 3. So when I execute this, what is it I am expecting now? It happens in a sequence. The assignment happens in a sequence here. A1 is getting the value of 2, A2 is getting the value of 3. So when I print it, I am able to see the outcome coming out correctly. This is how the multiple assignments work out. Also, I told you, you can delete variables. Remember, what is the definition of variable? Variable is nothing but a memory location. You are defining a memory location to store the value that is assigned to the variable. Now I am going to delete a variable. So what is it going to happen there? It's going to delete the memory location assigned to a variable. Now let me execute this and show it across to you. What happens? When I delete the variable A1, I have deleted the variable and then I am printing the variable A1. Now, do you see the outcome? The error is coming up. Why? Because I have already deleted the variable. Now when I am trying to print that variable, Python compiler is not able to find out where that variable is because it's deleted already. That's why you get this error. It is saying that it's a name error. This A1 which is being asked for, I'm not able to find it because we have deleted that. If I change the lines of code, like if I had put the line of code like A1 and then del A1, it would have given me the value of A1 and then it would have executed del A1. So automatically the value would have come out and then it would have deleted it. I hope you are able to understand the sequence of things that are happening here. Good. We'll take a pause here. We will learn data type casting in the next topic and then come back here and do things hands-on again. See you in the next topic. Thank you. Welcome back. In the last topic, you understood the different types of variables and the different data types. Now what we are going to learn in today's topic is, we are going to understand how we can cast different data types. What do you mean by casting? Casting is nothing but you are going to change the type of the data that you are storing in a variable. If it is an integer, can I convert it to float? If it is a float, can I convert it to integer? Like this, I can change different data types depending on my business needs. So there are two types of casting. Let's understand that. If you look at it, casting is all about changing the data types, isn't it? And I told you, this Python has a beautiful feature where we say that the type can be casted internally without we explicitly calling it out. That is, Python itself would recognize the change in the data type and it would update accordingly because the compilers are so smart. Now look at this. This is what we call it as implicit type casting. This happens automatically with Python to avoid any data loss. For example, if I say I want to add an integer number and a float number and then I would like to store it in a new variable, I can very well do it. Like 3 plus 5.5 would result in 8.5. Now this 8.5 is a float. Now if you are storing it in a new variable, even though you may declare it as integer, it can still store the float value and it will be updated to float as the data type. This is what we call it as implicit typecasting. Python does it consciously to ensure that the data that you have stored in these variables are not lost. Addition of an integer and float is completely done in this way. That's just one example. You can try different data types and Python is smart enough to do this. Now moving on, there is a second type of casting, what we call it as the explicit data type casting, where we say that I can create functions or I can use functions to change one data type to the other by explicitly calling it out. So I can convert int of x, that is I say that integer is a function and I'm passing x as a variable to it, and that will convert x into an integer irrespective of what that data type is. Same way, if I use strx, string is the function I'm using and I'm passing x as a data to it, variable to it, and I'm able to convert x into a string representation. Similarly, the float and the bool, the other data types that we studied in the last topic, we can use them to convert the values to float or boolean data type. Same way, we have certain other variables also. Like we discussed in the last topic, there are boolean data types and we also have binary data types. Like that we have x and oct. These are some of the functions that you can use to convert integer to hexadecimal or octadecimal numbers respectively. Now let's look at some examples for you to understand before we move on to hands-on. Take this simple assignment. Is equal to 11001. Is it a string or is it an hexa? What do you think? It's a string, isn't it, since we are putting it in quotation. Now I am converting it to the integer. I am saying c equal to int s comma 2. Now when I print this, like after converting to integer base, what is the value that I am going to get? Let's check that out. I am printing c. Can you guess before I show the results? After converting to integer base, the value comes out as 25. That is, the value c stores the value 25. So you can see the output on the right side. Same way, I have a complex data type. I say 1, 2. Now let's look at the second example. The variable c has complex 1, 2 passed across to it. It means that I have some data 1, 2 which I want to convert it to complex variables. Now when I print c, what do you think the output will be? 1 plus 2j. Normal 2 set of integers are converted to complex data type here just by passing it to complex function. Same way, let me use x. hex as a function when I use it and I pass 66 as a data to it. What do you think the output will be? The output will be 0x42 and it's a float. What you can say, float of 11011. That's what has happened here. Same way, if I use octadecimal as a function and I pass 65 as data to it, I get the output 0, O. If you notice the difference, x was used as a symbol for hexa in the previous function. Here it's octa, so I'm using O. So 00101 is the output I'm getting here. I hope you have understood what data type casting is all about. So what we have discussed so far is two types of casting: internal type casting or implicit type casting we call it as, and then we have explicit type casting. Now it is time for us to try this hands-on in Python directly. Are you ready? Time to do hands-on. Let's get to the Jupyter notebook which we created earlier for variables and data types. Now, as you can see, I'm going to do some exercises to show you how implicit and explicit data type casting happens. So implicit typecasting, let's start with that. I'm assigning a variable a with the value of 5, and same way I'm assigning 3.4 to the variable b. So a is integer, b is float, as you can see. Now I want to add a plus b and assign it to c. That is, I am assigning an integer and a float. I am adding both of them and then assigning it to variable c. So c is becoming float implicitly. When I print c, you'll understand that the value is 8.4, and when you check the type of c, it should be float. Can we check that? As we expected, the variable value is 8.4 and the variable data type is float. Now you have understood implicit typecasting, which is one of the advantages of Python compared to other programming languages. Now let's understand explicit typecasting. I am assigning the variable f with a value complex 1, 2. That is, complex is a function where I am assigning the variables or passing the variables 1, 2. Now when I assign this, f is going to become a complex data type. So let me print it and see. Now as expected, since I have passed 1, 2, the variable has become 1 plus 2j, which is of type complex, as you can see in the outcome. Same way, I can convert integers, I can convert hex and octadecimal. Let's see how we can do it. Integer based conversion, yes, 11001. I am assigning this value to the variable s, and I am passing integer function with these variables s and base 2. That is, I am converting it to the base 2, integer base 2. Now when I print it, what is the value? This is the example that we saw earlier in our topic. The variable is converted and the value is 25. G carries the value of 25 now. Same way, if I have to try hexa and octadecimals, I am just printing x of int of s and oct int of s. The conversions are done. That is where I say that the direct conversion from string x to x is not possible. So I have converted the string to integer, and then from integer I am converting to hexa, and from integer I am converting to octa. That's what has happened, which has resulted in the right conversions. I hope you are able to understand how the data type casting works in Python. As I always tell you, I would recommend you to try these things hands-on, explore more, learn more, practice more. Looking forward to you in the next session, in the next topic, where we are going to discuss more about other areas in Python. So see you in the next section. Thank you. Welcome back. Welcome to the new section where we are going to explore more about Python programming. In this section, we are going to learn about operators. When we talk about operators, we are going to talk about multiple types of operators that are there. We have assignment operators, we have arithmetic operators, we have comparison operators, logical operators, bitwise operators, identity operators, Python membership operators, and there is a concept called as operator overloading, which you should be aware as a programmer. We also talk about operator precedence. These are some of the topics that we are going to learn in this particular section. Can we move on to understand what operators mean? Let's understand what is operator. Operators are objects which specify a relation between two operands or two variables, and it can carry out an operation, a calculation, an assignment, and it can make a comparison. So operators are the foundational blocks when you talk about a programming language. Even Python has certain set of operators that are predefined. So there are different operators here, like arithmetic operators, assignment operators, comparison operators, bitwise operators, logical operators, and membership operators. In fact, in the next topic, you are going to learn about each of these operators, and let's get to do hands-on on how these operators work. So looking forward to you in the next session. Thank you. Today we will discuss about arithmetic and assignment operators. So what are they? We'll start with arithmetic operators. These operators perform various arithmetic functions between variables. Some of the well-known arithmetic operators, right from the school days we have been studying: plus, which stands for addition, minus for subtraction, asterisk for multiplication, and backslash for division, and percentage for taking the modulus. In fact, we have some complex operators also, like double asterisk. We use it for exponentiation. So if I put a double star 5 or a double asterisk 5, that would make it a raised to the power of 5. That's how we define exponential operator. Double backslash is another operator that is there in Python. It is floor division, which gives the quotient as a result on division between two variables rounded off. If one of the operands is negative, the result is floored or rounded in the negative direction. For example, minus 11 double backslash 3. What do you think would be the result? The result is minus 4. So this is how the double backslash operator or the floor division operator works. If you look on the other side, if you use percentage as an operator, it gives a remainder of a division operation between two operands. I hope you have understood what arithmetic operators can do for you. Now let's move on to assignment operator. Assignment operator is you can assign certain value to a certain variable with the help of this operator. As you can see on the screen, a simple assignment operator stands for equal to. If you want to add and assign, I will use something like plus equal to. If I want to subtract and assign, I'll put it like minus equal to. If I say divide and assign, I'll use backslash equal to. So what will happen when I use these operators? Let's take an example. Add and assign. If I have to give you an example to make you understand how this works. Let's say x plus equal to 3. This one stands for x equal to x plus 3. Likewise, you can apply the same concept for other operators. You can do it for add, subtract, multiply, division. Even modulus, exponentiation, and floor divide, which we discussed as part of the arithmetic operators. So an assignment operator, to summarize, it helps in assigning value to a variable, and equal to is a typical operator. And it usually assigns value from the right side operands to the left side operand. That is, as I mentioned, if it is x plus equal to 5, it is x equal to x plus 5. That's how we look at it. That's why we call it as right side to left side operand. I hope you have understood what arithmetic and assignment operators can do for you. Shall we try hands-on in our Google Colab observatory? Let's move on to the Google Colab. Now let's get to Google Colab and start trying things hands-on. So I've created a new notebook as I showed you earlier, and I'm just renaming it to Learn Operators. Now let me start with a basic one. That is how to start with an assignment operator. So let me put across a comment to begin with. For comments here, I'm going to use hashtag. So that indicates it's a comment. So x equal to 10. That means I'm trying to assign the value of 10 to x. Now I have executed this. let me see whether I'm getting the value of 10. You can see that the code is getting executed and the cell is executed now. Very good. Now let me go for a new line of code and check out the value of x. Now ideally this value of x should be 10. So let me print that. You can see 10 that is coming out as an output. So we have understood the assignment operator, how this works. Let's take some complex ones. If you remember, I was teaching you how we can write an addition plus assignment operator. Let's take that. X plus equal to 5. What do you think the output would be? I am just adding x also in the same line of code so that I need not write two lines of code to execute this. So line 1 and line 2 both are available here. Let me execute this. As expected, the value of output is 15. That is, x already carries a value of 10. Now 10 plus 5, that is x plus equal to 5 means x equal to x plus 5. X already carries 10, 10 plus 5, 15, and it is assigned back to the value of x. That's why x comes out as 15. Now moving on, let's also understand the division operator, division and assignment. Do you remember that? Let me put it across for you. Division and assignment operator. I have just typed y is equal to 30, y backslash equal to x. That is, all I am trying to say is y is equal to y by x, as I explained earlier. Now what do you think the value of y would be now when I print it after this assignment is done? Let's check that out. The value is 2. So this is how the assignment operator works. In fact, I can even type some print statements. You have not tried print earlier. So let me give you a new set of statements which you can learn. I'm just saying print the new value of x. That is, print the value of x and print the value of y. And I'm concatenating a bit of a text before the value is printed. So I'm saying print colon the new value of x is, and then I'm giving the variable x. Now when I execute this, the output will be the new value of x is whatever value we got earlier, that is 15. Let's check that out, whether we are getting those right values. Yes, whatever we got in the earlier executions, that's coming out as a right value, and we have understood how to use the print statement. Remember, there are two fundamental statements that you have learned. If I directly give x, you are able to see the output as x. But if I am able to add print to it, I am able to combine certain text along with the variable. And that's what is making a difference here. Okay, if you compare the line number 3 and the line number 4 and the line number 5. In line number 3 and line number 4, you can see that I've just directly printed the variables x and y without using the print statement. So whatever that was assigned to it, the values are coming out. But in line number 5, I'm consciously using the print statement, which is helping me to see the outcome that is coming out. So this is something you should be aware of. Okay, so now this whole concept explains how the assignment operators can be coded in Python. Now slowly I'll move on to the arithmetic operations. Remember, we discussed both in the session earlier. So assignment is done. Now let's get to arithmetic operations. Let me start with the foundational one. Can I start with the exponential one that we discussed? So what is the operator for it? The operator for it is double asterisk. So z equal to y double asterisk 5 is something that I have coded here. That means raising y to the exponential power of 5. That's what I want to do here. If I print z, what do you think the output will be? Let's check that out. This is nothing but 2 to the power of 5. That is nothing but 32. You can see the output here. So floor division, this is something we tried. I hope you understood the concept when I explained to you. Let's try that hands-on. When I do floor division, it is double backslash. That's the command, that's the operator for it. Let me put it across and see how those operations perform. I am just coding it like C equal to Z double backslash X. That is floor division rounds off the result. That's what I wanted to do. Now let me print C and how the value is coming out. The value is 2. That is, the value of Z is 32. 32 double backslash 15. If you remember, X carries the value of 15. So it is giving me the value of 2 because 32 divided by 15. Twice you can divide 32 by 15. 15 into 2 is 30. That's how this is coming out. Then what is a modulus operator? Can we try that once? So modulus operator actually gives me the remainder of the division. When I divide some variable, it is actually going to give me the remainder. So let's check that out. M is equal to X percentage Y. Percentage is the modulus operator that we learned earlier. When I apply this and when I try to print M, the value of M is turning out to be 1. I hope you're able to understand this concept. Okay. Now, in this topic, we understood how the assignment operator and the arithmetic operators work. We have learned multiple operators. In a short span of 10 to 15 minutes, you have learned nearly around 10 operators. Now, I would request you to try yourself once by writing these lines of code. I'm sharing this particular notebook in your resources which you can download, but I would humbly request you to try this hands-on by yourself so that you are confident, you know what you are typing and you are able to see the results. In the next topic, we will understand more about comparison operators. So I'll see you in the next section. Thank you. Welcome back. In today's topic, we are going to discuss about comparison and logical operators. So what are they? Comparison operators are used to compare two variables or two operands on either sides. Usually the outcome of these comparison operator is a Boolean value. If it matches, it's 1. If not, it is 0. So comparison operator is used in different coding projects, primarily to check whether the values are matching or not. So some of the comparison operators are double equal to, that is, it checks whether A is equal to B. If A double equal to B returns true, that means A is equal to B. Exclamation operator and equal to, it checks whether A is not equal to B. If A exclamation operator equal to B returns true, that means A is not equal to B. We have greater than operator and lesser than operator, which we know what it is. Greater than operator checks if A is greater than B. It returns true if A is greater than B. A less than B checks if A is lesser than B and returns true if that is so. Greater than or equal to checks if A is greater than or equal to B and returns true if that is the case. And it returns false if that is not the case. And same way, A lesser than equal to B checks if A is smaller than or equal to B and it returns true if A is smaller than or equal to B. So I hope you have understood what comparison operators can do for you. Now let's understand the logical operators. So logical operators are more like Boolean operators, and it takes us back to the good old school days, if you remember. We have logical AND, logical OR and logical NOT as part of these operators. Logical AND is if both the variables, if both the operands are true, the result is true. If any one condition is true, then the result will be true if you are using logical OR. And means both the conditions should be met, or means even if one of the conditions are met, you will be able to perform that operation. Logical NOT means this gives the inverse of the value given as input. If it is true, the outcome is false. If it is false, the outcome is true. That is logical operator. In fact, let me show you some examples of how these logical operators work. So if you look at the screen, A and B, A0, B1, A or B means it is 1. Because even if one of them is true, I'm going to consider it as true. That's what OR operator defines for us. AND means 0 and 1 will return 0. Because I want both of them to be 1, only then I'll get 1 as an output, as you can see on the table very clearly. NOT operator, as I explained to you, if you are giving 0 as an input, you get 1 as an output. If you are giving 1 as an input, you are getting 0 as an output. This is how the logical operators work. Now it is time for us to try this thing hands-on in our Google Colab. I hope you still have that operators notebook open. We will try our hands directly there. Thank you. Now time for us to try it in our notebook. So I'm going to try it with comparison operators. As explained, the purpose of comparison operators is to check between two variables which one is greater or smaller or equal to. These are some of the operations that we can perform. Now take this one. So we know the value of C, which has come out to be 2 earlier, as you remember, and Z is 32. So I'm just printing C colon C exclamatory mark equal to Z. So what do you think the value of this would be? And I'm also printing print C greater than or equal to Z. And I'm using a comparison for if condition, as you can see on the screen. If C is lesser than or equal to Z, print C is smaller than Z. If it is greater, nothing will be printed. So this line of code, let me execute and show it to you how the comparison operators work. So first step, we are checking whether C is equal to Z. Since we have used exclamation mark, we know that C and Z are not the same. 2 and 32 are not equal. So it is printing true because we have used the exclamation mark. Now the second one, print C greater than or equal to Z. Whether C is greater than or equal to Z, 2 is not greater than 32. So it prints false. Now we are checking print, check if C is less than or equal to Z. Yes, 2 is lesser than or equal to 32. If that is the case, I am asking the Python compiler to print C is smaller than Z, which it has actually rightly done so. So this is how the basic comparison operator works. Now let's move on to logical operator. Let me take a new line of code and let me try to execute these couple of lines. We know C as 2, Z as 32. We know the value of these variables already. Now I want to check whether C is equal to Z and C not equal to Z, that is exclamation mark. Let me execute this and see whether the logical operators are working fine. Remember, the logical operators are AND, 0. These are some of the operators that we discussed. If both the variables are returning true, then the outcome will be true. If one of them is true, then if you use OR operator, then the outcome is true. So AND expects both to be true. Now here we have two operands, C equal to Z and C not equal to Z. So can we check what the outcome is? I am executing this piece of code. It comes out as false because one of them is false. Which one? C equal to Z. So I'm checking whether 2 and 32 are the same, which is not the case. So one side of the condition is false. So automatically, being an AND operator, it's going to return false. This is how the AND operator works. Now let me try the same thing in a slightly different format. I'm going to check the same in a slightly different one. Let me see whether this works. I want to print C not equal to Z and C lesser than or equal to Z. C is lesser than or equal to Z, which we are all aware of. So what do you expect? True or false? The answer is true, as expected, because both of them are returning true. So true and true will return true. Let me check with the logical lesser than operator. Print not. If you remember, not operator, and or and not is the third operator that we discussed in the logical operators. I am checking not C lesser than or equal to Z. That means I am checking whether C, that is 2, is less than 32, which is right, that is true. But I am putting a not in front of it. So automatically, the answer that I would expect here is false. Since logically the operand is giving me true, and I have used a logical operator of not before that, it is giving me not true, that is false. This is how the logical operators work. So in this topic, you have tried both comparison operators and logical operators hands-on. As I expected, you have got a good idea of how this works. Now it is important for you to practice this more. Try different permutation combination of these operators and practice more so that you can learn and you will understand, and it will slowly get memorized in your mind that this is how these operators operate. Thank you very much. See you in the next topic. Welcome back. We are going to learn a set of new operators in this topic. I'll start with bitwise operators. What do you think the bitwise operators can do for us? They can perform logical operations bit by bit by converting the values to 8-bit values. Let's say, for example, we assume A is equal to 54. Its 8-bit value is 00110110. Of course, you need not memorize this. The system will be able to do this for you. Let's take one more. Assume B is equal to 66. Its 8-bit value is 01000010. All the possible bitwise operations are covered with the help of A and B. So what kind of operations you can do? When we talk about bitwise operators, we have bitwise AND, bitwise OR, bitwise XOR, bitwise ones complement, binary left shift, binary right shift. These are all the different operators that exist when we talk about bitwise operations between two variables A and B. I'll explain it to you one by one. Binary AND, which is usually represented with the help of ampersand. It performs a bit by bit AND operation. That is, if you're asking for A ampersand B, that is, we consider the value of A as 54 and B as 66. Now it's going to look at the 8-bit value of 54 and 66 and then compute this operation of ampersand, this operation of AND. So the outcome of it will be 00, 00, 00, 00 and 10. Now compare the 8-bit values of 54 and 66, you will be able to understand this. Same way, you can also perform OR operation or exclusively OR, that is XOR operation. When we say XOR, it talks about copying the bit if it is set as 1 in one operand. So that's how the XOR operation works. It is usually represented with the help of the exponential symbol. Binary ones complement can be applied to one operand and each bit's comp. That is, when you say tilde, the tilde, what we call it as, that is the usual representation of this binary ones complement. Tilde A means 1100 1001. It is just doing the opposite. You can do left shift, you can do right shift. So overall, if you notice, the binary operations can be easily performed with these bitwise operators. You are converting everything into zeros and ones, 8-bit value, and then you can play around with these 8-bit values with the help of all these operators. I hope you got some clarity about bitwise operators. Now let's look at identity and membership operators. So what do you mean by identity operators? The Python identity operators are used to compare the objects to see if they are actually the same objects or variables with the same memory location. If you remember, we can assign value to a variable, we can assign reference to a variable. So when you are assigning reference to a variable, it is the same memory location that you are trying to tap. So you are using identity operators to check whether two variables have the same reference or using the same object. That's what we are trying to find here. So there are two identity operators here. One is, the other one is not. So when we say x is y, it returns true if both variables are of the same object. If I say x is not y, it is going to return true if both the variables are not the same object. So in a way, this is helping me to assess and understand how the identities of the objects are, how they are stored. Now moving on, we have Python membership operators. These operators primarily test for the membership of operand on the left in a sequence on the right. The sequence can be a list, it can be string, or it can be tuples. So these are some data structures which you are going to learn down the lane in this program. But for now, let's assume that they are different data structures. So some of the operators here are in, not in. When we say in, it evaluates to true if the operand belongs to the same sequence. Not in will return true if the operand does not belong to the same sequence. So this membership operation is primarily to check whether they are in the sequence or not. So in this particular topic, we have understood three different operators: the bitwise operators, the identity operators, and finally the Python membership operators. Now it is time for us to try this hands-on using our notebook. So can you please open your notebook? We will try things together. Thank you. Now let's get back to our Jupyter notebook. Let's try bitwise operators hands-on. As you can see, I've just taken A as 54 and B as 66, as we discussed in the presentation earlier. The bitwise operations or the binary digits for 54 is 0011 0110, and for 66 the 8-bit value is 0100 0010. Now if I am going to do binary AND, what will happen? So I am saying A and B, what would be the value of it? Let's check that out. I'm just printing A and B. Let's see what the value is turning out to be. The value of A and B is 2, as expected. This is how the bitwise operator works. Let's try binary OR now. A pipeline B, that's what we want to test it out and see what the value of it would be. So when you are going to take A and B and use an OR operator in between, which is usually the pipeline symbol, the pipe symbol, what we call it as A or B, the value of it turns out to be 118. That's the outcome we are expecting. Same way binary XOR, that is the symbol for it or the operator for it is the exponential symbol A exponential B, A to the power of B. Now when we execute this, the value of it comes out to be 116. This is how the bitwise operators work. Now let's get to the complement side. Remember, we also discussed that there is a binary ones complement as another operator. That is, with the help of a tilde symbol, you will be able to execute things. So if I have to print the tilde of A, the A is already 1100, 1001. It actually does the tilde and it prints it. The value turns out to be minus 55. Same way you can do binary left shift. That is A less than 2 equal to, what would the value be? The value turns out to be 216. If I do a binary right shift, A greater than 1, the value turns out to be 27. So I hope this gives you a small idea about how these bitwise operations work. Let's get to membership operators. The membership operators help us to understand where those variables belong to. X equal to belongs to, Y equal to this article belongs to me. If X in Y, in is an operator, membership operator, if I test it out, it's going to check and tell me whether string X is a subset of string Y. So when I execute this, I'm ensuring that we are covering and checking whether string X is a subset of string Y. Yes, belongs to is a word which is there in the phrase, this article belongs to me, so I'm getting it as a true. Straightforward, isn't it? Membership operator. Same way, identity operators can be used. What is identity? As I told you, is and is not are the identity operators. If you check whether X is Y, you can say that X and Y are 5 and 5 each. And if you're testing whether X is Y, it's going to check whether both are equal and identical. Okay. Now when we execute this, it's going to give me the value of true because both are 5. Same way, I execute it with a string, with an array. M is equal to 1, 2, 3. N is equal to 1, 2, 3. And I'm printing whether M is N. It comes out as false because even though both these values are equal, they are not identical. They are stored in different memory locations. You need to understand this concept. Equal and identical are not the same. Equal means both values are the same and both are stored in the same location. Identical means values can be same, but they are not stored in the same location. As you could see here, M and N are carrying the same set of values. But when I am testing whether M is N, it is not giving me the same result. It is coming out as false because these data are stored in different memory locations. So this is where identical feature is false. So obviously the output is false. Let's move on. If X is equal to 10 and Y is equal to X. So what I'm trying to do here, I'm assigning a value of 10 to X and then assigning that X to Y. Now X and Y are essentially made the same objects. Now if I try this code X is Y, will it come out as same objects or different objects? They will come out as same objects. Here, they are identical. They are assigned to the same operator. So this comes out naturally as true, thereby it is printing they are same objects. Now let's try the same. Z equal to Y. We already have X equal to 10, Y is equal to X, and now Z equal to Y. Now Z is also the same object as X. Now can I try whether X is Z? Yes, very much. The output will be they are same objects because X, Y and Z are all pointing to the same objects. So the value will remain the same. I hope this gives you an idea of how the bitwise operators, the identity operators are working. Please try by yourself. Spend some 15 minutes. Try these codes, try these operators, different combinations, because only when you try coding with your own hands, you are going to remember these operators. Let's connect again in the next session and understand what is operator overloading. Thank you. Welcome back. In today's topic, we are going to learn about operator overloading, precedence, and operator associativity. We'll start with operator overloading. It is a very common challenge with many programming languages, including Python. The overloading happens when a same operator is used to carry out different kinds of operations. For example, take plus. The plus operator can be used for addition of two variables as well as concatenation of two different strings. The same operator for two different purposes. This is what results in operator overloading. Sometimes we need to explicitly define what operator overloading is so that we are avoiding certain situations. Sometimes those operators may not be compatible with the data type of the objects, which may result in challenges for you. So this is operator overloading, explicitly defined in certain situations to avoid conflicts. Now let's move on to operator precedence. Precedence is defined as the order of importance or preference for execution for Python operators. If you remember the BODMAS principle, it is pretty similar to that. This defined order is especially important when many of these operators are used together in the same statement. So which one has to be executed first? That's a natural question. So if you look at the order of precedence, Python follows this order that you're seeing on screen. It starts with the exponential operator, the double asterisk. If that comes out in a particular statement, this takes priority or precedence over other operators. The second one is multiply, divide, modulus, and floor division. These operators take the second priority in the order. The third priority is plus or minus. The fourth one is comparison. Fifth one is checking the equality, equal or not equal. The sixth one is assignment. Either double equal to operators and or all those operators come into picture. And then finally the logical operators, that's where the and or everything come into picture. So this is the order that Python follows when it comes to executing the statements. You will slowly understand while we get to the hands-on exercise why this becomes more important. If you don't execute in this order, then automatically the results are going to be different. Because without a rule of law, you won't be able to do the calculations, do the arithmetic calculations in the right manner. I hope you have understood the importance of precedence and the arithmetic precedence table. Moving on, the next topic is operator associativity. The precedence gives a precedence level to the groups of operators. That's what we have understood. When the operators in the same precedence level are used together, that's when the associativity comes into picture. It decides the flow of execution in these cases. For example, we spoke about multiplication, division, then percentage and, that is modulus, and double backslash. They are usually executed from left to right. This is what we call it as associativity. This is predefined and can be changed by the use of parenthesis. You consciously use parenthesis to tell the Python compiler which should be executed first, which should not be. So I hope this also gives you a clarity of how the operators are used in precedence, what are the hierarchies that exist, and how they will be executed when the lines of code are written. Shall we try these exercises hands-on? Let's get to the Jupyter notebook which we were executing earlier, and let's continue to practice. See you there in the Jupyter notebook. Let's try things hands-on in our Jupyter notebook. We discussed about operator overloading. Let's look at how we use the plus operator. So I've just written few lines of code to show how the plus operator works. So I've taken A and assigned value 34 to it, and I've taken a variable B and assigned 23 to it. What does C stand for? A plus B. What do you think I'll get? So 23 plus 34 is the value that I'm expecting. Now when I say prints addition of the numbers, when I print C, the value 57 comes out, that is 34 plus 23, but the output is still a number. Now if I say using plus operator on strings, just like addition, I'm using the same operator for concatenating strings, adding two strings. Let's say string 1, my name is, string 2, Deepak Kumar. So if I say str, that is new string, is nothing but string 1 plus string 2, actually it just concatenates the two strings. Now when I try to print it, it just prints it out as my name is Deepak Kumar, which is very much right. Now how are we going to do operator overloading? So operator overloading is done with the help of greater than operator. Let's say for example here I'm using the greater than operator to show you how this can create challenges. A class like object here cannot be used. So class soldier, I've defined a new class soldier. I know that I have not introduced the class concept yet to you, but for now let's assume that it's a basic function. And I'm defining a small function which passes self, name, age and weight as variables to it. And I'm assigning for each class self.name equal to name, self.age is equal to age, self.weight is equal to weight. Now Martin, I would say soldier Martin 3678, that is I'm saying it's the name, and then the age and the weight I have given and I am assigning to it. So I've got two variables now, Martin and the Russell. So Russell is soldier Russell 32 and 80, that is 32 years and 80 is the weight. Now if I am going to use greater than operator on these two functions, Russell and Martin, do you expect it to work? Is Martin greater than Russell or Russell greater than Martin? You need to check that. Do you think functionally this is logical? It won't. It won't return the variable because greater than is not supported between the instances of soldier here. That's the error that we have got, which is valid. To make this work, a function can be defined which can perform the required operation. So what I'm doing here is I'm defining a greater than function instead of using greater than operator. This is what I told you earlier, that I'm consciously defining and explicitly defining the definition of the operators to avoid operator overloading. So I'm saying the self dot weight is greater than other dot weight, so that I can compare the weights of two different people, Russell and Martin, by defining a function called as greater than. Now all I have to do is I have to use this greater than function, pass these both names, Martin and Russell, into it, and then expect the output, as you can see here. So when I execute this and execute the result, you can see that the answer is coming out to be false. That is, Martin and Russell, who is considered to be greater than, means obviously Martin is not greater than Russell. That's what we are getting it across. So the operation greater than is performed successfully here. Because the weight wise, if you notice, 78 is Martin's weight, 80 is Russell's weight. Obviously Martin is not heavier than Russell. That's why you got it as false. So I hope you are able to understand the foundational concept here. When you are using the same operator for multiple purposes, you are going to face the problem of overloading. To avoid overloading, we are consciously defining functions. And then we are using these operators inside those functions, so that the explicit definition is going to help the Python compiler to give you the right answer. I hope you have understood the concept of Python operator overloading here. Now let me move on to operator precedence, the second concept that we discussed earlier. Precedence means I told you that certain operators are executed in certain fashion. There is a priority, there is a precedence in the ways the operators are executed. Now let's look at some of the operations here. I hope you understand this concept with these examples. I'm assigning 54 to A and I'm assigning 2 to B. If I do A multiplied by 2 plus B exponential to 3, that is double asterisk I'm using here, what do you think I would get it as a value? Let me execute that and show it across. Remember, all operators are coming from different precedence levels, so it's going to be challenging when I'm going to print C. C gives me 116 as an answer. How? A multiplied by 2, that is 54 multiplied by 2 is 108, plus 2 to the power of 3, that is 8 again. So 108 plus 8 is 116. That's how you got the answer 116. So there is a precedence in the way the operators are being used across in this function. So try different combinations, because this is one common problem you are going to face. I have seen my data scientists making some mistakes in these kind of operations, and this resulting in an error when the clients are checking for the output. So understanding this foundational principle of operator precedence is important, because which one gets executed first will actually determine the result that you are going to get. So use the operators correctly, use parentheses correctly to group them logically and to get the right outcome. Now I'll move on to the third concept we learned earlier, operation associativity. When operators of same precedence levels are used in a statement, that's when the associativity comes into picture. Like A is equal to 24, B is equal to 11, and I'm creating C, which I define it as A multiplied by 3 percentage B double backslash 2. So remember, I told you when we are using associativity principles, we are going to execute it from left to right. So A star 3 will be executed first, then percentage B, then double backslash 2. Now let's look at the outcome of C. The C value is 3. Now connect the dots and see. 24 multiplied by 3 percentage B, that is 11, and then double backslash 2 will result in 3 as an outcome. This is how associativity principle works. The use of parentheses can also help you to override the above associativity rule that you saw. So let me define the same thing here. A is equal to 24, B is equal to 11, but I'm using parenthesis when I'm defining C. So I'm saying that 3% B in a parenthesis, so this takes precedence before executing A star 3% B. So the one in the closest loop, in the closest circle, in the parenthesis is what is going to be executed first, and then we are going to execute the rest. Now let's look at the value. Let's see whether your guess is right. If you execute this, the value of C would be 36. So one important thing that you need to remember is, when there are multiple operators used in a single statement, associativity comes into picture and you start executing it from left to right. And if you're using parenthesis here, effectively, the parenthesis takes precedence while you are executing things. Still you are executing left to right, but you are starting with the operation within the parenthesis. You execute that first before moving on to other operators. So this whole notebook, I'm going to upload it in the resources tab. Please do download it. Please code, please execute and see whether you are getting the same results. Now this is the first step towards learning a new language. And apart from whatever executed, that is around 38 lines of code I'm passing it across to you, you are going to try a few things hands-on. I'll also add an assignment here so that you can practice and come back. Thank you. See you in the next section. Welcome back. In the last section, we understood what operators are. We are able to deep dive and see what are the different types of operators that exist. Now, having understood the data types, variables, and operators, it is important for us to jump in and understand certain special elements that are available which can help you in programming. This is conditional statements and the loops. In this particular section, you are going to learn about the conditional statements, the different types of conditional statements that exist, what we call it as a simple if-else statement, if-else, elif and else statement, nested if-else statement. We will also understand how the loops in Python works. Again, there are different types of loops. We have for loop, while loop, and while break and continue. So I am excited to share my knowledge with you in the upcoming topics. I hope you are interested too. See you in the next topic. Welcome back. In this particular topic, we are going to understand conditional statements. Before I get to the topic, you need to understand why this topic is important. Remember, the purpose of the programming language is to create solutions that can solve business problems. So when we are writing code, when we are trying to solve business problems, we are going to have multiple scenarios. To handle those scenarios, to build in that business logic, we need conditional statements and loops. So this particular topic is very, very important. It may look easy, it may look simple, but at the end of the day, this is one of the powerful concepts that you need in any programming language to solve some of the critical business problems. So shall we learn conditional statements in detail? I'll start with what conditional statements are all about. You want a certain kind of a flow when you're writing a program. To create that flow, you need certain statements. That's what we call it as conditions. Based on the conditions, you are creating some statements which will decide the flow of execution of the program. So you want a certain block of code to be executed if certain conditions are met. As the name indicates, that's why it's called conditional statements. If else, if, elif, else are some of the basic foundational statements that are available as part of the conditional statements. In this particular topic, we will understand all these three types of conditional statements. I'll start with simple if statement. It has a very simple syntax. If this condition is met, execute this intended statement. As you can see, it's more about this condition and the intended or indented statement block. So whatever you have given as part of that block is going to be executed if the condition is met. The condition is generally Boolean in nature. Either it carries the value of true or false. If it is true, then the block is executed. If it is false, then we don't execute that block. For example, if marks is greater than 50, please print the student has passed the exam. Only if the marks is greater than 50, this particular statement of print will be executed. If it is not, nothing will happen because it's just a if condition. Now, if you want an alternate execution, that is if the marks is not greater than 50, you want to print, let's say for example, the student has not passed the exam. Is there any other statement that's available for you to execute? Yes. That's where we have this concept of if-else statement. So I may say that if the condition is met, that is if it is true, execute this particular code. If it is not true, you are giving an alternate piece of code to be executed. This is what is determining the flow basis the condition. If the condition is met, one block is executed. If the condition is not met, the other block is executed. So this is how the whole if-else block works. Now moving on, we also have a third part, if, elif, else statements. So if and if-else statements check for single conditions. But here, if you have multiple conditions, then you can bring in this concept of if, elif, and else statements. So check out this flow chart. So if the condition is met, there is a body of if that is going to be executed. If the condition is not met, again you are creating another set of conditional workflows where you say that elif, that is again you are saying else plus if. Since the condition is not met, it is else block. There again you have an if block. So you combine it and call it as elif block. There you again put across conditions like if the condition is true, a certain block to be executed. If the condition is false, again that block can be executed. So with multiple scenarios coming into picture while you are trying to build some solutions for a business problem, such kind of building blocks can be put across so that you are able to embed the right business logic into the code. I hope this gives you a good idea of what if, elif, and else statement can do for you. We also have a concept called as nested if-else statements. Nested if-else statement is we are going to have multiple conditions and I'm going to put it as conditions within conditions. Sounds like the Inception movie? Similar to that. So we have if condition and then we are getting into it. If this condition is executed, if this condition is true, I'm going on to the next condition. Again, if this condition is true, then execute this piece of code. So step by step, in a cascaded manner, in a nested manner, I'm executing pieces of code. As you can see on the left, you can see the condition very clearly. If condition 1 is met, if it is true, then condition 2 is checked. If it is true, then the statement block is executed. If it is not true, then I'm using elif block and I'm checking condition 3. If the condition 3 is true, then again the statement block is executed. If not, you have another set of statements that will be executed. If the condition 1 itself has not been met, if that is false, then I'm going for elif and then else statements. So this is called as a nested if. What you see in condition 1 is called as a nested if because I have put multiple if conditions under the nested loop. One by one it is going to check. Depending on the combinations, depending on the cascading effect, the result will be executed. A certain block of code will be executed. You have understood conditional statements now. You have seen multiple conditional statements. Nearly 4 of them you have seen. Now it is time for you to try hands-on. Shall we get on to hands-on? Please keep the Jupyter notebook ready. We'll connect again in the next topic and do this hands-on. Thank you. Welcome back. In the last topic, we discussed about conditional statements. We also saw different conditional statements that you can use in the programming to solve business problems. Now here, we are going to do certain things hands-on. What I would recommend is, in the same Google Colabs, I would suggest you to create a new notebook, conditional statements and loops, and let's start coding from there. I'll start with simple if statement. Remember the examples that we discussed in our PowerPoint presentation. We are going to use the same examples and we are going to execute them in Python and see how the results are coming out. I'm just assuming that marks is 80. I'm assigning the value 80 to marks, and then I'm checking with the help of simple if statement. If marks is greater than 50, I'm going to print that the student has passed the exam. Now, if I execute this, what do you think the result is going to be? The result is the student has passed the exam because the marks carries the value 80 and 80 is greater than 50, which returns true Boolean. And if the condition is true, then it prints or executes the code that has been given there. This is how if statement works. Now let's move on to if-else statement. I told you, if you want to have an alternate logic to be defined, if the Boolean condition is false, then you go for if-else statement. So we are saying that if marks is less than 50, print the student has failed the exam. If the mark is greater than 50, I want this to be printed that the student has passed the exam. Now this is if-else business logic. So I've written it with certain blocks for either conditions. Now we know that marks is 80, 80 is greater than 50. So we are expecting the first block to be executed since the condition is true. So here the student has passed the exam has been rightly executed because the condition is false. The marks is not less than 50. So the condition is false, so automatically the alternate block is executed here. Now moving on, the third one that we studied in the last topic was if, elif, else statement. It's more like multiple if-else conditions. How can you code it? Let me show you how it is done. A is equal to 200, B is equal to 33. I'm assigning these values. And then I'm checking if B is greater than A. If 33 is greater than 200. That is not the case. So automatically the next block gets executed. But before that, let's check the block that will be executed if this condition is true. If B is greater than A, I want this to be printed that B is greater than A. Else, if A is equal to B, that is if A and B are equal, then print that A and B are equal. If that is not the case, print A is greater than B. Now we know A is 200, B is 33. So A is greater than B. That's what is going to be executed. But look at the 3 lines of code or 3 blocks of code that we have written. The third block is getting executed here because of the conditions that the code has checked. The first condition has failed, the second condition has failed, and it has got to the third condition, and that's where the code is getting executed. So when I execute this, I'm expecting this to be printed A is greater than B. I hope you have understood how this if, elif and else statements work. Now let me try one more example for this because this is slightly complicated compared to the traditional if-else statements. Max marks is 40, English marks is 30. I want to check the max marks and English marks, and then I want to print certain conditions. Like if max marks is greater than 50, I am asking the computer to print, please check the marks for max subject. If max marks is greater than 50, and if the condition returned is false, that is the Boolean response is false, then it comes to elif marks, that is else if marks English is greater than 50. If this is true, then it's going to print, please check the marks for English subject. Now it is very clear how the code is being written. If I execute this, what do you think the output will be? The output is marks entered are valid, the total score is 70. 30 plus 40, as it is expected, the third block has got executed and it's printing the marks. So 2-3 learnings from this one. One, you have understood how the multiple if-else statements can be executed, especially using if, elif and else. The second part is, you can also see that when you're executing the print statement, you're also using or calculating certain things directly. Like max marks plus English marks, you're able to sum it up and then you're able to print that. This is something new that you're learning now. Please keep this in mind. Now, having said this, I'm moving on to nested if-else statement. So nested if-else is the same objective as above. Whatever we achieved with the help of if, elif, I can achieve the same by using nested if-else statements. That is cascaded if-else statements. If the condition is true, then another condition, then another condition. So I am bringing everything into a nested format. So check this one. If max marks is greater than 50, print this, else just put across another if condition where you say that if marks of English is greater than 50, print this, else this. Now when I execute this, the same output is going to come up. Marks entered are valid, the total score is 70. But I have written it slightly differently with nested if-else. By the way, these are all options that are available for you. You have the complete liberty to choose depending on what you would like to code and how you would like to code it. But please understand, there are different options available here. So it is completely at your liberty to do this. So feel free to choose the right one and execute this. I hope you have learned something new in this particular topic. We'll connect again in the next topic where we are going to learn more about loops, another important concept in Python. So see you in the next topic. Welcome back. In the last topic, we discussed about conditional statements and we tried few things and so on. Now it is important for us to understand loops, another logic that would help you to code better to solve some business problems in the market. So what is a loop? Let's understand that better. Loops are used where a condition is to be tested for a number of values or iterations. So you're creating a loop and you're executing certain things for a certain set of values. That's why the loop is used. So loops can be run on a list of values as well as where each iteration can test a condition for all values of that list. This is how the loops are executed. So if you notice, the first loop statement that you're going to learn is for loop. The for loop can be used to iterate over arrays, sets, tuples, strings, lists, etc. I know some of the terms may be new to you. Don't worry about it. We are going to learn data structures in the upcoming sections and you'll be able to understand these statements. But all you have to remember now is these data structures can store multiple values. So to go through multiple values of those data structures, for loop can be used. And these are zero indexed loops. When I say zero indexed, it starts with the zero value. That means the first character or the first item in the loop is actually denoting to the value of 0. That is, when you say this particular 0 value, that you are referring to the first item in that particular list. Check this out. The syntax, when I write it, like for I in range of 10, print I plus 1. For values to start with 0, I plus 1 is required. Thus, you're starting with 0 and then slowly you are indexing it, and then you are printing I plus 1 as a result of it. As a part of for loop, we also have something called as nested for loops. These can be used for creation of two-dimensional arrays. When you have multiple dimensions within the same array, for each dimension you may need to have a separate for loop. So it's more like for loop within for loop. For every first item, iterate all the second ones. That's what we call it as a nested one, isn't it? Just like the nested if-else condition that we discussed earlier, where we have an if condition within a broader if condition. Here we are talking about nested loops where you have a loop within another for loop. It's especially used when you have multi-dimensional arrays. Depending on the number of dimensions you have, you will have number of for loops in a nested manner. Like for example, for I in range 11 and for j in range I, you're printing I and you're printing j. So in a way, step by step, you're printing things and in a cascaded manner. That's what we call it as a nested loop. So while we talk about loops, it is also important for us to understand certain functions associated with the loop. When I say len, it talks about the length. So this helps me to understand the length of the list that I am handling. Sometimes I may not know how many items are stored in the list. If I use this particular attribute, len, it helps me to identify the number of items in the list, and accordingly I can write my for loop. From 0 till this particular length, you are going to run the loop kind of, and this really helps. When I use range, this is another function very similar to len. When I use range, it is helping me to create iterations of a desired sequence. Instead of going through the full number of items in the list, here I am saying that I will do it only for a certain range. Range means I am going to give the starting point and I am going to give the end point. So it is going to help me to just run the for loop only for these items given in the range between the starting and the ending point. So I hope you have understood what for loop can do for you. Now let's understand while loop. So for is for iterations, while is also for iterations in a list, but it's based on a different concept. So what I'm saying here is, when I say while, I'm going to use an expression, and basis that expression, till that expression is executed, I'm going to execute certain set of statements. Unlike if statement, while keeps on executing the block in a loop until the condition is met. So for is about meeting a certain condition, you're executing certain items. Here, you're executing everything till a certain condition is met. The while loop executes at least once as the condition is true for the first time. That may not be the case with for also. But here you're executing it at least once because you execute the condition and then you check, you execute the statements and then you check the condition. So this makes a difference. In case of a condition which can never be false, that is like infinite loop, Ctrl C helps to stop the program execution. You may not face this situation in a real programming world because generally you are aware of when to stop the execution and the conditions for the while statement is very clear. But somewhere if you're stuck, then you may use Ctrl C. Now depending on your needs, you may either use the for loop or you may use the while loop. While using the while loop, we also have a concept called as break and continue. To break or terminate a while loop completely, you can use the break statement. Similarly, continue can be used to skip an iteration of the loop. So both has its own purposes when you are writing your code. Check out how this code is executed. N is equal to 5, while n is greater than 0 and n minus is equal to 1, and if n equal to 2, that is if n carries the value of 2, break and then print n and then say loop ended, because you are coming out of this loop when you say break. We'll execute this shortly in our next topic and see how this code gets executed. But this is how the flow chart is. While n is greater than 0, you are saying print loop ended. If not, you are going to check n equal to 2 and then create a break in the while loop. So as I mentioned earlier, both has its own advantages and disadvantages. Depending on your business needs, what you would like to execute with a piece of code, you can choose either for loop or you can use while loop. I hope this gives you a clarity. It's time for us to do this thing hands-on. So get your Jupyter notebook ready in your Google Colab. We'll connect in our next topic and do this hands-on. Thank you. Welcome back. We discussed about for loops in the last topic. Now it is time for us to do hands-on on both for loops as well as the while loops. I opened the Jupyter notebook and I've shared it across. I hope you also have opened your notebook and you're going to try things hands-on with me. So I'll start with the for loop, what we studied in the last topic. I mentioned that the index starts with 0. It's all 0 index loops. So it starts with 0. For I in range 10, print of I, when I say, what do you think the outcome will be? It's going to start with 0 and it's printing up to 9. That is, the range is 10. So automatically we have 10 different items in the list that's going to get published. So since the index starts with 0, it is printing 0 to 9. So I hope you have understood why we are saying it's a 0 index start. Now let's look at for loop for numbers. How can we concatenate even and odd numbers from a string of numbers? Let's look at that. I have a number defined, 1253, a random number, as you can see on the screen. Even and odd, I would like to just keep adding those numbers in this. Now remember, this numbers is actually a string. String means it's an array of characters. It has a list which has multiple characters in it. Now I'm executing the for loop to see and check for every character whether it is number, that number is odd or even. So I'm executing for num in numbers, and if integer number, that is, since I'm taking a string and then character by character I'm passing it across in the for loop, I'm doing an explicit type casting. If you remember that, we studied this couple of topics back. Implicit and explicit typecasting. I'm doing explicit typecasting here. Integer number of %2. That is, I'm converting num. Let's say 1 is passed across. I'm converting that one character into integer and then doing a percentage. I told you earlier, percentage is nothing but the modulus. We studied this in the operators one. So it is taking the remainder. If the remainder is 0, that means it is even. If the remainder is not 0, it is going to be odd. Now depending on whether it is even or odd, you are just adding those numbers in the even list. Okay, you are concatenating all even numbers in even by saying even plus equal to num, which is nothing but even is equal to even plus num. So I'm printing it and I'm getting the outcome. What do you think the outcome will be? Let's check this out. When I execute this, I've got all evens here, as you can see on the screen. 2, 6, 8, 4, 2, 8, 2, 4, 2, 6, 8, 0. All the even numbers are concatenated and put across in one particular string, and that string is printed. Same way, all the odd numbers are concatenated and they are put across in odd. Now are able to understand how the for loop is used. And we are taking a character, we are taking a string, and we are looking at each and every character in the string with the help of for loop. And this is what is helping us to take character by character, assess and convert them to string, from string to number, and then we are looking at it whether it is a even number or an odd number with explicit typecasting. Now let's move on. If I have to use for loop for strings, how is it going to work? Let's take a simple string, twinkle twinkle little star. For every letter in string, I want to print it. Remember, this is pretty similar to our last exercise. I've taken a string. It's an array of characters. For every character, I am printing it. So what do you expect here? As you can see on the screen, every letter is taken, and in the loop, it is going through that particular string, and the whole string is printed. I hope you have understood how this for loop works. Now, nested for loop. I told you nested for loop is multiple for loops. Especially when you have multiple dimensions, automatically you are going to use nested for loops. Now, as you can see on the screen, I am saying for I in range 11 and for j in range I. I am taking a nested loop here because I have two dimensions, I and j. And I am trying to print I and try to see how the row is going to be executed. So let me execute this. You can see this. For every character, I am getting multiple sequences. So for every I, j is getting printed. So it's getting into a nested loop. That's the reason you're seeing such type of numbers printed again and again, because the print is within that loop statement. So depending on where you're putting across the print, you are able to see how that loop is executed. And it has consciously been written this way so that you understand how the loop is getting executed. Moving on, you can use range. This is something we discussed. Using range for a different step of 3 in iterations. So what I'm trying to say here is, I'm going to use a for loop for I in range 1, 30, 3. I say that the range is between 1 and 30, but I'm going to use this in a kind of step format. That is for every third number. Skip two numbers and then go to the third one. That's what I'm trying to say in the name of different step of 3. By default, the step is 1 if you don't mention it. If you consciously mention the step, like here for example 3, it's going to do the looping in terms of 3. So let's execute it and see how the outcome comes out. As you can see here, it starts from 1 and it completes well before 30. 1, 4, 7, 10, 13, 16, 19, 22, 25, 28. Do you see the step of 3 here? That's what you can achieve with this range value. Moving on, for loops, for list. So list is something that you're going to learn down the lane as a data structure. But to begin with, a list is something where you can store any type of variable. It's a data structure. Okay, you can see number, you can see strings that can be put across. So in a list one, I'm saying multiple different variables are put across 1, 2, 5, hello, ABC. Now when I print this, what will be the outcome? As you can see, it iterates every item in that particular list and it prints that, since the print is kept inside the for loop. This is how the for loop for list work. Now check this one. I want you to try this by yourself. Objective 1 and objective 2. Read this out very clearly. Understand how this is getting executed. I'm going to give this piece of code. I do not want to execute this here in the session, but I want you to try this out and explore how this is done. Moving on, I'm moving to dictionary. Dictionary is another data type where I say that I'm going to have a key value pair kind of. I say, for example, look at this one. Player 1 colon Rohit Sharma, 103. 2 colon Virat Kohli, 56. 3 colon Shikhar Dhawan, comma 78. 4 colon Ajinkya Rahane, comma 91. I have 4 values here. And I'm clearly indexing them 1, 2, 3, 4. And for each key value pair here in this one, I can run the loop and I can check out what values are stored there. As you can see, I have written the code like for key comma val in player.items. That is, player is the list that you have defined here. I'm going to take it item wise and I'm going to execute that and I'm going to get this key value pair printed. Let's see what happens. As you can see, the corresponding values are printed. So 1 Rohit Sharma, 2 Virat Kohli, 3 Shikhar Dhawan, 4 Ajinkya Rahane is printed. In fact, you can also print the keys alone. So I can, instead of saying items, if I use keys, you can see in the previous one I mentioned player.items. I'm using player.keys here. What will happen if I use this player.keys? It's just going to print the key alone, not the value. So 1, 2, 3, 4 is the key. The value here is Rohit Sharma, comma 1 or 3 is the value. Now if I have to print values, let's check that out. As I mentioned, it just prints the values, not the keys. Now, can you count the number of players who have scored runs less than 100? Because what you have stored in players is, you have got the player name and the corresponding score. Now I want to identify the players who have scored less than 100. Is it possible? Yes. I am combining 2 different concepts here. The for loops that you have learned in the last topic and the if loop or if conditional statement that you learned earlier. So check out the code. For count is equal to 0. For key value in player items, just like how we have written earlier, if value of 1 is less than 100, remember value of 1, not 0. If value of 0 is given, it would return the name like Rohit Sharma, Virat Kohli, Ajinkya Rahane. If I say variable of 1, value of 1, it talks about the second one. That's where the score is stored, isn't it? Now when that value of 1 is less than 100, then count that. Because I just need the count. I do not want to know the person. If I want to know the person, I can print the person also directly here, isn't it? So count plus equal to 1 and I'm printing the count. Let's see how many players are going to come up. What is your expectation? The value should be 3, isn't it? Because Virat Kohli, Shikhar and Ajinkya, all 3 of them have got scores less than 100. Let's execute this. As expected, the answer is 3. I hope you got a clarity of how the for loops work. In fact, I also showed you a combination of for and if else so that you're able to understand how you can put it across to solve certain problems. Now moving on, we understood while loop in the last topic. What is a while loop? The loop gets executed till the condition is met. Let's check that out. Counter is equal to 0. While counter is less than 3, keep on executing this. Else, print inside else. Let's check that out, how this is getting executed. So, inside loop is printed 3 times. 0, 1, 2. The moment, that is 3 times it is printed, the moment the counter becomes 3, this particular loop will not be executed. So automatically the inside else is printed. So I just executed the code and I showed you how till the counter becomes 3, you are able to see the value inside loop printed. The moment it becomes 3, the inside else is printed. That's why you find 4 statements very clearly printed here. Now moving on, we also understood break and continue as part of the while. So what does the break statement do for you? How does it work? I'm assuming that n carries a value of 5 here. While n is greater than 0 and n minus equal to 1, that is incrementally I'm reducing the value 5, 4, 3, 2, 1 because n minus equal to 1 means n equal to n minus 1. the moment n equals 2, break the code. Till that becomes 2, you're going to execute that while loop. And keep printing n continuously till n becomes 2. And then you say loop ended. Now let's see how this gets executed. You will understand the output very clearly. So n is equal to 5. While n is greater than 0, it's getting printed. So 5 minus 1, 4 has come in, and then the print statement is used. So 4 is printed across here. Then now again back to the loop. 3 is coming out now. 4 minus 1, 3 is printed. Now again back to the loop. 3 is reduced by 1, it becomes 2. Now the if condition becomes active because n is equal to 2 now. So the loop is broken now. The loop is broken and it comes out, thereby the loop is ended. So I hope you have understood how the break statement works. Now continue. Continue is another powerful statement when it comes to while loop. N is equal to 5, while n is greater than 0. I have just taken the similar example. N minus equal to 1. If n equal to 2, continue. Instead of break, I am just using continue here. Now let's see how this works out. Is it going to break and come out? Because you saw the output when I used break. Now I am using continue. How do you think this code will be executed? So now what has happened is, it has just skipped that particular iteration when n has become 2. So it has become 4, 3, and it skipped when n has become 2, and then it has come down to 1, 0. And finally loop ended. Clear difference, isn't it? Break and continue are two different important statements that you can use within the while loop. I hope you have understood through this particular hands-on exercise how you can use for, nested for, and the break continue in while loop. Please try this by yourself again, trying different pieces of code. Execute things hands-on, then you will be able to learn this concept in a better way. I'll see you again in the next section, and let's learn more about Python. Thank you. Welcome back. In the last few sections, you understood what is Python, why Python is useful in solving some problems in the market and the society. And slowly we understood the coding aspects of Python. We started with variables, then operators, then data structures, data types. We covered a lot of aspects. In fact, data structure is something that we are going to deep dive in this particular section. I spoke about list and other aspects earlier. I'm going to deep dive and explain to you what the lists are and the other data structures that are available in this case. So let's deep dive, let's get to the topics, let's understand these topics of data structures in a better way. See you shortly. Welcome back. In this particular topic, we are going to understand what a data structure is and how is it different from data types. To begin with, you need to understand why this data structure is more important and more widely used in the market. For that, we will start with understanding the problems that exist with the existing data types. If you look at the existing data types, let's say you want to store an integer, a character, a string, a float, everything in one particular data type. Do you think it is possible? Not possible. Because each and every variable that you define is actually going to have something of similar nature. I can only store integers in one particular variable. I can only store float in one type of variable. If I have the task of storing a book name, price, and the number of copies sold, everything in one list together, that is, I am talking about storing one string, float, and an integer value in one place together. Do you think it is possible for me to use the data types and do it well? Not really. So the data in a data type is stored in a single format, either it is string or integer or float or boolean. So single data point is stored, so large memory requirement, that is a challenge with respect to the data types. And actually this is not suited for large structured data, especially when you want to store in sequence or in a particular order. This is where the data types have a handicap. Now this is exactly where the data structures are going to help us better. Now with this problem in mind, the data structures were introduced, where we are able to see multiple solutions coming in this format. We have list, we have dictionary, we have tuples, and we have set. In fact, these 4 types are available as data structures for us to process some complex logic and to store data which are available in multiple data types. So that's what makes data structures predominantly used in the market, especially in the Python programming. So let me start with a list. What is a list? List stores an ordered collection of items which might be of different types. We already saw that. Like for example, if you take a library, I can take the book, I can look at the number of copies that have been sent across, and I can also look at the author, which may be a string. So different data types I can put it across in one place. The elements that are contained within a list are separated by commas and are enclosed in square brackets. This is how you call a list. When we do hands-on, you will understand this better. Look at this example. 1, 2, 3, ML and Python. We have 5 different items stored across, and this is one particular value. So separated by commas, we are able to store multiple values. This is how the list can be defined. Now moving on, let's understand dictionary, the second data structure that we saw earlier. When we talk about dictionary, it is unordered mapping for storing objects. Remember, list is about an ordered variables, ordered set of data stored in one particular area. But when we talk about dictionary, we are calling it as unordered mapping for storing objects. It stores data in the form of key value pair. If you remember it right, in the last section, when we are discussing about a particular list, do you remember that we were using Virat Kohli, then Ajinkya Rahane, Rohit Sharma, a kind of a key value pair in a particular match, in which order they played and what was the score that each of the batsmen got? Do you remember that example? That example is a good example for this dictionary because we store data in key value pairs. You don't need to know the index location when it comes to dictionary. And dictionary uses curly braces. List, we were talking about square brackets. Here we are talking about curly braces and colons to identify the key and associated values. Look at this example. We are using curly braces, key 1, value 1, key 2, value 2. That's a combination that we are looking at. So it's a key value pair when you store it, and when you do not want an ordered list, then you can look at dictionary as an option. So I have understood 2 data structures so far. Now let's move on to the third one, tuples. So what is a tuple? It is pretty much similar to the list. But however, there is one key distinction, immutability. So what is immutability? You can't reassign the elements. You can't change. Immutable means not changeable. You can't reassign the elements that are stored in a tuple. So tuples use parentheses. Just like we saw squares, braces. Now we are talking about parentheses for tuples. So you are using parentheses and say 1, 2, 3. That means this is a tuple. That's the third type. Of course, when we do hands-on, you will be able to understand all these aspects in a better way. We'll move there shortly in the next few topics. But the fourth one you need to understand is a data structure called as sets. So what is a set? Set is unordered collection of unique elements. You can't have a repetitive one, you can't have a duplicate value stored in a set. So if we have some kind of items where the duplicates is not permissible, like for example Aadhaar number or mobile number kind of data, if you want to store it, then set can be a perfect data structure that you may look at. So set is an unordered collection of unique items, and addition of new elements can be done in a set. What kind of operations you can perform? You can perform operations like union, intersection with a set. Now you have understood what a set is, and you have understood 4 different data structures. Just to recollect it quickly, just to summarize, you understood the problem with the existing data types, whereby in the existing data types you can't store multiple formats, integers, string, and all those things. If you want to store it in one place, it is not possible with the existing data type. That's where the structures come into picture, the data structure comes into picture. So when we say data structure, this gives us the liberty to store elements of different data types. The example that we saw was bookstore. So like that we can store multiple things in one common place. You have 4 different data types: list, then dictionary, then tuples, and then sets. Now it is time for us to explore this hands-on and understand the difference between all these 4 different data structures. I'm sure it's going to be an eye-opener for you. But one thing I would request while you do this hands-on, when you're trying it, please think about a practical application. When will you use dictionary? When will you use tuples? Depending on their properties, start thinking about how it can be applied in a real-world context. So see you in the next topic with your Jupyter Notebook. I'll be ready with my Jupyter Notebook to show you how this can be done. Thank you. Welcome back. This is time for us to try few things hands-on. We discussed about data structures in the last topic. Now let's explore and let's do more on this side. Now to look at data structures, I've just quickly shared my screen. We are going to start with list. List being the basic foundational data structure, we are going to perform a lot of operations on the list so that you're able to understand the different things that we can do for this list data structure. So I'm going to show you how to create a list, how you can index and slice them, how you can transform list to other data structures like tuples, dictionaries, and other aspects. How can you add new elements to a list, delete elements from a list, sort them, then iterate over items of a list, and then how to comprehend list. So we are going to learn all these aspects in this particular topic. Let's look at it one by one. First step, I'm creating a simple list containing a set of integers. I told you when we talk about list, it's the square brackets that we use. So as you can see, I've just put it across list1 equal to, in square brackets, 1, 2, 3, 4, 5. Now when I execute this, it's going to create a new list1 and it's going to store these values in that particular list. Of course, this list has only integers at this point of time. Now when I print list, I'll be able to see what is stored. As expected, it has stored all these values. Now I'll also show you how to create a list with multiple data types. Take this one, mixed list. Mixed list is equal to 1, Mumbai, Pune, and 5.55. Do you see different data types here? I've got integer, then string, and then the float. All 3 of them assigned to one particular list, and I call it as mixed list. Now when I execute this, the mixed list will be created. Now this is created. Let's check out the values that are stored. So mixed list has come out this way. Now, are you curious to check what the type of this data structure would be? Let's check that out. I'm just using type as a simple function and I'm passing mixed list as the variable to it. Now this will give me the type that is there. And as we created a list, the type is also list. Remember I told you about length when discussing about the for loop and other aspects. Now I'm using the same function to find out how many elements are stored in the list. So to find out, I'm using len, length. The short form of length is len here. Len, and I'm passing mixed list into it. When I execute this, 4 comes out as a result. Why 4? It's 1, Mumbai, Pune and 5.55. 4 items are stored in the list and as expected, the value 4 comes out. Now let me create a list using range or list keyword. Okay, till now I did not use a list keyword. I directly tried assigning elements to the list. Now I'm going to use this list keyword to create a new list. Let me show you how. New list is equal to list range 1, 6. So I'm saying that I'm going to create a new list using the list function and the range is 1 to 6. Range 1 to 6 means it's going to take up the values from 1, 2, 3, 4, 5. And it has just assigned it to the list as the values as the elements in the list. So the range 1 to 5 gets these 1 to 5 numbers into that as elements. And when you're putting it across within the list parenthesis, automatically it's going to create a new list with those elements added to that list. So you can see 1, 2, 3, 4, 5 directly available as a list. Now what you have understood so far is nothing but the basic functionality of a list data structure. We understood how to create a list. So you understood 2 different ways. One is directly assigning all the variables, all the elements directly to it. You can use length to find out. And the second option is you can use list as a kind of a function to create a new list. Now addition of a new list is something that you are aware of at this point of time. That means creation. Now what we are going to learn now is how to select one item from the list. How is the list going to be represented? We can access any item from the list using the index operator. So if you put something in the square brackets, the index value when you put it across, you will be able to fetch the items. So now let's play the new list. Let's understand what is there in the new list which is already created. Remember 1, 2, 3, 4, 5 is available in the new list. Now you also need to remember the whole thing that I mentioned. The index starts from 0 when it comes to list. So 0 and not 1. If I say new list 2, can you make a guess what would be the value of this particular one? Will it be 2 or will it be 3? Let's check that out. The value is 3 because it starts with 0, 1 and 2. So 3, third position is what we are trying to fetch. So 1, 2, 3, 4, 5, it is fetching the third position, that is value is 3. I hope you got an idea now. Now the same way we can do reverse indexing. So what we have done now is indexing from the beginning. So if I want to do reverse indexing, in certain areas we may use this while we are trying to develop a solution. So let's understand how to do reverse indexing. So it starts with, we call it as a negative indexing also. We start with a negative value that is fed in as an input. So index value that you pass across should be negative when you talk about reverse indexing. So new list minus 2 is what I'm going to execute now to find out what is the value. Minus 2 means it comes from the back. Now 4 is the value that we have got. But have you noticed something? From the back, when you are checking it, it is not 0, minus 1 and minus 2. It is directly minus 1 and minus 2. So when you are doing reverse indexing, it is not starting with 0. It is directly starting with minus 1. So I hope you are able to understand the indexing operations. This actually helps you to choose how the lists are functioning and how you can play around with the items in the list. Now sometimes you may get index out of range errors. So when will you get that? When you have an integer value greater or smaller than the length of the list, which is passed across to the index operator. It means you are referring to an index that is not there in the list. This is going to create some trouble. So obviously the Python compiler is going to look for the particular index value which is actually not there. Then that is a challenge. So it's going to result index out of error, out of range error. Now let's see new list 5. Do you think you have a value for it? We have new list 4, that's a maximum. Now when I press this, it's getting me the index error because this particular value 5 is not there. So list index out of range, you have got that error as we rightly pointed out. Good. Now you know how to select items in the list. Now let's look at selecting multiple items from the list. So slicing is going to be used here to fetch multiple items or range of items from the list. In this case, instead of just an integer, we also put a colon in between the double brackets. So this will help you to understand why we are using it. Let's take mixed list. Let's understand what is there that is stored in the mixed list. We have got 1 Mumbai, Pune and 5.55 stored there. Now when I say mixed list 1:4, it's going to fetch me the items between 1 and 4. That is here, I'm talking about Mumbai, Pune and 5.55. These are the 3 elements that are stored in the range between 1 and 4. Now if I want to select certain items, the first 2 elements of the list, let's say for example, then I am going to store it this way. I'm just going to execute mixed list in brackets :2. Let's see what comes up. This shows that I'm just going to fetch the first 2 items of the list. Absolutely. The values 1 and Mumbai are returned. So these are the first 2 items that are stored there in the list. If I want to select all the items of the list after the second value, then you guessed it right. Mixed list, and I'm using 2: without a end array. So I'm not talking about the end. So all the items that are there after the second position, I'm going to pull them out and I'm going to show that across. So when I execute this, you can see that after the second value, that is Pune and 5.55 are the 2 items in the list which are getting printed. I hope now you have understood how multiple items can be selected. Now let me also show you how to slice along with step size. Step is something I showed it to you earlier when I was talking about certain loops, conditional statements of the loops. Step by default carries a value of 1. Now if we call out explicit value for a step, accordingly the behavior of the outcome will be different. Let's check that out. So what is the syntax for this? A and then start :end :step. So I am talking about the range and I am giving a step. Let me show that across to you. So take my list and I am just creating a range now. 0 to 10, I am going to pull the values and that is getting stored in the name of list, which is stored in my list. So when I execute this, the my list is created. Let me see what my list carries. So as you know, it stores from 0 to 9 because it carries the range from 0 to 10. Now when I select values from 0 to 7 with a step size of 3, that is 0 to 7 means 0:8 :3. That is step is 3 here, so I am consciously mentioning it as 3. Now let me print this and let me see whether you are able to get the right values. 0, 3 and 6 are the 3 values that are returned. 3 elements of the list that are returned. Considering it's a step size of 3, you have just got the 3 values. If you had not mentioned the step value of 3, you know the outcome. I want you to try that and see. So try different step values and check out how the response is. Now here I will take a pause because we have covered a lot in the last 10 to 15 minutes. My request, try these things once, try yourself, write your own code to execute these things. While in the next topic, we are going to understand how to convert these lists into multiple other data structures. So see you in the next topic. Thank you. Welcome back. In the last topic, we understood how different operations can be performed on a list. Now in this particular topic, we are going to learn about how the Python list can be transformed into multiple other data structures. So let me get back to the notebook. I hope you have the same notebook ready. So I am converting a string to a list. How can I do that? So I'm just creating a simple string here. Welcome to this course. So when I create this, I am carrying the string welcome to this course assigned to text, and I'm just executing it. When I execute this, the text is created. Now I am converting that list. Actually, I'm splitting the text what I've got, and then I'm assigning it to the list. Let me execute this and show it across what happens. So welcome to this course. That's what has been split up. So I had 4 different words, array of different words coming out in the form of a string. Now this particular string of text, txt, I'm just splitting them. The moment I say split, automatically bases the blank spaces, it has been split across. So it knows that there are 4 words, welcome to this course. Now all these 4 words are added as elements to the list. So that's what has happened. That's why when you print the text underscore list, you're able to get this outcome. Now let me do the same thing. I'm creating a new text and I'm saying that, hi, welcome. Today we will learn about list. Let me execute that. Now the new text is created. Now let me split them with a specific parameter or a delimiter, that is full stop. The period is something that I'm using here to delimit, to split the complete words. Can you make a guess? If I split this with a period, what do you think would be stored across in this text underscore list? Can you tell me how many elements will be there? Yes, you guessed it right. We had 3 different sentences here. Hi, welcome. Today we will learn about list. All the 3 are stored as 3 different elements, considering we have used period as the delimiter. So this is how we convert a string to a list. Every character or every word, or based on the delimiter, every sentence can also be added as an element to the list and a new list can be created. Now, can we do the reverse thing? Can I convert a list back to a string? Let's understand how. Let me go back to the last text list that I created. That is, hi, welcome. Today we will learn about list. The 3 elements that are already there in this list. Now let me check the type. It should come out as list, isn't it? Because this is a new type. Now, what I'm going to do is, I'm going to use a delimiter, and then I'm going to say that, just like I use a split on the other side, I'm going to use join on this side. So how am I going to join it? With a space. That's why we see quotes here. Let me execute this, and I'm storing it in alpha. Now let me print alpha and see what is there. Good. We have got all the 3 elements added now, and the new list has been created just with the space added in between, isn't it? This is exactly what we expected. Now check out the type of alpha. So what is your expectation? Will it be list or will it be a string? It will be a string. So you have taken all the elements and you have put it across in one particular string. Same way, let's try one more example. List carries 5 different or 6 different alphabets A, B, C, D, E, F. Now I'm using hashtag and then I'm using join. Can you guess what the answer would be? Let's see whether your answer is right. As you saw in the previous one, we used a space. Here we have used an hashtag. So you are getting this response: A hash, B hash, C hash, D hash, E hash and F hash. This is how the operations can be performed. Like either you can convert from a string to a list or from list to a string. Now let's also look at how to convert list to a dictionary. If you remember, list is something which is coming out with the square brackets. But when you talk about dictionary, we talk about slightly a different format, isn't it? Let's see what that format is. So I'm defining a simple list, name underscore list. I've taken 5 different names. I've just created a new list. And I'm assigning marks. I'm creating a new marks for each one of them. So 80, 72, 87, 92, 16. This is another new list that has been created. Now I'm going to create dictionary. If you remember right, when we discussed this topic earlier, I told you dictionary is a combination of a key and a value. You have a key value pair that is stored in a particular data structure. Now here I am defining that what is the key and what is the value and how it is going to be stored in one place. So my underscore dict is the dictionary name, and I'm using dictionary function dict, and I'm saying zip name underscore list and marks underscore list. This is going to help me to create a dictionary. Now the dictionary is created. Let me print my dictionary and see what is there. You can see this very clearly. Uday colon 80, Suraj colon 72, Raju colon 87, and this is what is stored in the simple dictionary. Now check the type of my dictionary. It is very clear. It is dict. Now let's convert a list to a tuple. You have understood list and how it can be converted to a dictionary. Now let's understand how the list can be converted to a tuple, which is another data structure. Tuple function can be used to convert a list into a tuple, just like the dict function, which was used to convert it to a dictionary. So I've taken my tuple and then tuple of my list has been assigned to that. So tuple function is used across, and I have passed list as a variable into it. Let me check out my tuple and what is stored there. So it has got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember my list? Earlier we had created with the help of range 1 to 10. That's exactly what this is. Now let's check out the type of my list. Type of my list is list. Very clear. And type of my tuple is tuple. So we're able to convert the list to a tuple very clearly here. Now in the same way, can I convert the list to another data structure, set, in Python? Just like you had dict for dictionary, then tuple for tuple, now we have set as a function to convert a list to a set. So same way, I have my set, which is created as a new set, and I'm passing my list to a set function, which is going to help me to create a new my set. Now when I print this my set, I can see that the values are stored in the same way, but I hope you're able to see the difference. Now this comes in parentheses, the curly braces, if you remember. Now this is different from the tuple where you saw it in direct braces. So you understand the difference. Now when you check the type of my set, set is the answer. So this is how you can convert multiple lists into different data structures. Now I want you to try all these things, explore these functions better, try creating new lists and convert them to different data structures. While in the next topic, I'm going to talk about how you can play around with the values in the list. We will cover that in the next topic. See you in the next topic. Thank you. In the last topic, we understood how to play around with the list. We understood how the list can be converted to different data structures. Now here, in this particular topic, we are going to understand what kind of operations that you can perform on a list. Adding, deleting, all those operations we'll learn in this particular topic. Now I hope you have got your Jupyter notebook ready. Let's do it together. So to begin with, I'm going to start with how you can add value to the list. When I say add, it includes 4 different operations: assign, append, extend, insert. Let's look at each one of them. Assign. Let me take a small example. I've got a list. I'm creating a new list, my list, which will have a range 0 to 10, which I'm embedding it as a list, and then I'm doing it. This is something we have already executed, so you know how it works. Now when I print my list, you get the values 0 to 9, very clearly documented. Now you can use an existing index number to alter the value at that index. So let's say my list of 0 is equal to 99. That means you're saying the first value of this particular list, I'm going to change it to 99. Shall we try that? Let's see how the my list is now after assigning 99. Now you have changed the list. Now you're able to change the value from 0 to 99. Now you know how to assign. Just by pulling up the index value on the list, you can assign values and thereby the list gets updated. Now let's come to append. Append is used when we want to add a single value to the list. So let's take, for example, take the my list. It had 10 values. So automatically the length, when you try to check using the len function, which we learned earlier, it's going to return the value 10. Now I want to append one more value to this list. Like we started with 0 to 9, we changed 0 to 99. We have 10 values. I want to add the 11th value. So my list.append 90. What will happen? It will add 90 at the beginning or at the end. It will add it at the end. Let's check that out. So now you can see 90 getting added there. So append is helping you to add values to the list. Now again check the length. Now it is going to show 11. Sometimes when you are maintaining some data structures with multiple values, you may use such kind of operations to ensure that you are not disturbing the existing values. You are just appending values to the list. Now let me go for the next one. Extend. Take my list. Let's understand what is there in my list. These are the 11 values that are there in my list now. Now I want to add one more value to this list. So I want to extend this, adding one more value. So I'm saying my list dot extend, and I'm saying 4 different values. Remember in the earlier one, when I said append, I just added one value. Now here I'm adding 4 different values and I'm extending it with 4 different values. Shall we see how this operation is performed? We have got all the 4 values added here: 200, 300, 400 and 500 added to my list. Now check out the length. From 11 it has increased to 15. So append and extend adds the new values at the end of the list. But in case if you want to add values to a specific index, you can use insert. You have seen different ways of adding values to the list. The 4th way or the 4th approach is insert, when you want to add it at a specific index. So I want to insert value 999 at the index 1. So what should I do? I'm just saying my list.insert. I'm giving the index value 1 and I'm adding the value 999. Now when I click this, actually the value at 1 is inserted with 999. Let me check the outcome. Remember, it is not 1 getting replaced by 999 here. I am adding 999 in that index value 1. That's the reason you see 99 at 0, 999 at 1, and then the value that was earlier at index 1 has moved to index 2, that is 1. So this is how the insert can be done. So just to quickly summarize before I move on to the next one. You can perform 4 different ways to add values to the list. So what have we done? Insert, to insert it at any index value. Then you add append, then extend, and then finally we also add assign. So 4 different ways you can add values to the list. Now moving on, I am going to teach you how to delete or remove elements from the list. How do we do that? Let's check that out. Again, 4 different approaches. I'll start with the basic one, del. So take the my list. I've created one just for the sake. I've just updated with these values. I just want to delete one item which is at a specific index. Here, for example, it's at value 2. So del.mylist 2. When I execute this, automatically the my list will be removed with the value that is at 2. So what was it at index value 2? The number 3. That has been removed from the list. So del function with the corresponding list name and the index value, when you put it across, you are able to delete a specific value from the list. When you want to delete multiple items, you can even use the range. So del mylist 0:4 means 0 to 4 all the items will be deleted. Check this out. All the initial values are deleted. 6, 7, 8, 9, 10 are available now. I hope you are able to understand how this works. If you want to delete the entire list, don't give the starting value and the ending value. Just use del directly. All the values in the my list will be deleted. Check this out. There is no value in this list. By the way, my list is still there. You have not deleted my list. You have just deleted values or the elements that have been stored in my list. So you have understood how to use the del function for deleting or removing items. Now let's go to pop. So remove method is used to remove the given item, and pop method is used to remove an item in a given index. So you're learning 2 different approaches here, remove and pop. So take the same my list. I'm just restoring it to the older values since we have performed multiple operations. I'm just adding and creating a new list with 1 to 10. Now let's say, for example, I want to remove the value at the last index. I'm saying mylist.pop. That means the last value or the value in the last index is going to be removed. So 10 has been popped out. Okay. Now when I print my list, so 10 is out of the list, if you notice. So it has popped out 10 and 10 is out, only 9 values are getting displayed. If I say pop out the value which is in index value 5. Now when you do that, 6 value is popped out and it has been removed from the list, as you can see. Now moving on, you have understood pop. Now let me move on to remove. Let's say my list carries 1 to 10 and then Pramod. Now remove the list value equal to 10. So mylist.remove 4. So what will it remove? Let's check that out. When you print my list with 4 passed across, you can see that the value 4 has been removed. So remove the list value equal to 10. That's what has been done here. So you have removed certain items from the list. So I hope you have understood how the remove function works. Now let's concatenate 2 lists. There are 2 lists that I have, A and B. How can I concatenate 2 lists? That is adding the elements of both the lists. Let's check that out. As you can see, I have 2 lists, list A, list B. A is this, B is this. Let me execute and create them to begin with. Now I am creating list total which is nothing but the concatenation of two different lists, list A and list B. Now let me print it and see what is the value. So 1, 2, 3 and 3, 4, 5 is concatenated, and I'm getting 1, 2, 3, 3, 4, 5 in one list. Now it is no longer two lists. I've stored them in one list, which is list total. Now let me explain to you how you can sort list. So you can create a list containing strings to begin with. So alf list is something that I've created. B, Z, V, R, P are the 5 characters that I've stored in the alphabet list. Now I want to use sort function to sort all the elements in the list. So I have something called as a sort function, sort open brackets and close brackets. When I pass this list and execute the sort function on that, the values in that list get sorted. Now when I execute this, can you see that BZVRP has been changed to BPRVZ? So alphabetically this is sorted just by using the sort function. So this has given me a good new sorted list now. So same way, if I use numbers, can I sort it in this way? Yes, very well. I'm creating a number list, I'm executing them, and I have created a bunch of values there. Now I'm using sort reverse equal to false. That is, in a way, I'm doing reverse sorting. What do you think would be the result? Check this out. Let's see whether you are right. Now it is sorting 5, 23, 45, 76, 98. So unlike the alphabetical order, it is going in the descending order, or the ascending order, I would say. That's the right word. So 5, 23, 45, 76, 98. That's how it has been sorted. So sort function doesn't work in case we have a mixed data type list. This is something you should be aware of. Now let me move on. I have something called as the reverse list. So reverse list means I've got a list that I've created 11, 2, 23, 4, 15, 6, 7, 8, 9, 10. Now I want to use the reverse function just to reverse the items on the list. Let's see what happens when I execute mylist.reverse. Check out the output. It just has reversed the values. Whatever elements that are stored in the list, 10 comes first, 9 comes next, 8 comes next. So the whole list of items are reversed in the new list that I have created. Since I use the same list and I have executed the function on it, the values are reversed and stored in the same list. Same way I can do iteration. How do I iterate over items of the list? So it starts with my list. I'm creating a new list. For every item in the list, do you remember the for loops? I'm bringing that concept here, and I'm saying that for every item in the loop, this particular list, I want you to print. So I've got 10 different items in the list. When I print it, I'm able to see it since it was in for loop. Now we'll look at how to sort the list. So I'm creating a simple list containing strings. Alf underscore list, which carries the values B, Z, V, R and P. Now, if I want to sort it alphabetically, all I have to use is sort function. So alf underscore list dot sort. So as you can see, it can just sort out the variables and it can give you the result like this. So in an alphabetical order, the values are coming out to be B, P, R, V and Z. Now same way, we can use a list of integer values like num list, where I have created with a set of integer values now, and I can do a sorting in a reverse format. So I say reverse equal to false or reverse equal to true. Depending on what I need, I can change the boolean values and I can run the sort. Since I have kept reverse equal to false, I am going to get the values like 5, 23, 45, 76, 98 in a kind of ascending order. So I hope you have understood how the sort function works. The sort function doesn't work in case we have a mixed data type list. Please keep this in mind. Now let's look at reversal of the list. This is another operation that we might need when we are trying to work on projects. Let's say we have a list created, my_list, with these elements put across. Now when I use a reverse function, what will happen? my_list.reverse, when I execute it, I'm going to get the complete set of values reversed, like 10 being the last one in my original list has become the first one in the new list. So reverse means I'm just going to reverse the index values of the elements in the list. Remember when I was discussing about the for loops, I also explained the concept of iterations. So when you take the list, I can iterate with each and every element in the list by using a for loop. Look at this example, my_list. So for I in my list, I'm just going to look at, for every element in my list, I'm just going to print out the values. So check this out, when I execute this, I'm getting the value of 1, 2, 3 up to 10, the 10 different elements that I have. So in a way, in a sequence, the values are getting executed, the print statement is getting executed, which is storing the values. The same way, I can also perform multiple other operations. Like look at this one. So I want to create a square of each and every element in the list and add it to square_list. So how can I use for loop here? For every element in my list, I'm saying num I*i. That is, every element, multiply it by the same value and store it in the square_list. How do I store? I'm using the append function. So when I do this, for every element in my list, it's going to be squared and it's going to be appended to the square_list. Check out the outcome. So it is clear. 1, 2, 3, 4 has become 1, 4, 9, 16 up to 100. So this is how you can actually perform multiple operations on a list. I hope this gives you some clarity. Now moving on, there is a concept called as list comprehension. Let's understand what it is. In a way, whatever you performed by using the for loop function earlier, I can present it in a slightly different format when it comes to comprehension. So check this out. I*i for I in my list. In a way, it is a crispy way of defining the statement, of defining the function. And I'm saying that whatever that you have got by writing few lines of code using the for loop, I'm executing it in one line. And this is called comprehension. Can it give me the same result? Yes, very well, it gives me the same result. Instead of writing 5, 6 lines of code, I'm able to get it in one particular line. How can I categorize ages in a list as young or old? So I have an age list that's available which carries multiple items. Now for each and every element here, if the person is less than 25, I can call it as young. More than 25 means I can call it as old. Now every element in this age list, this operation is going to be performed. So let's check out how this works out. This is a normal way of executing things. So every person's age, based on the performance, based on the if-else code that I've written, is identified as old or young, and the list is updated. But is there a way that I can use comprehension here to reduce the total lines of code and bring it to a simpler form? I can do that. So check out this one, age_category, and I'm using young if age is less than 25, else old for age_list. When I execute this, the same values or whatever the outcome that we expected from the previous one, we are going to get the same outcome. Isn't it very simpler? Of course, to begin with, it may look complicated for you, but as you practice, this is something you will feel very comfortable in executing it. Now print age category, you have got the same outcome. And this is what you have achieved with the help of these operations. So list comprehension is a simpler way of writing or executing some logic in few lines of code. I hope you have understood list comprehensions. We'll take a pause here. I would like you to execute all these commands. I've shared the notebook in resources. Please check them once. Execute all of them. In fact, I would suggest you to type in a new notebook and try your own permutation combination of these codes so that you are comfortable with these data structures. In the next hands-on session, I'm going to introduce you to other data structures. So see you in the next topic. Thank you. In the last few hands-on sessions, you understood more about list and what kind of different operations that you can perform on a list. Now it is time for us to move on and understand other data structures. We'll start with dictionary. So how to create a dictionary? Let me show it across to you. I told you dictionary is all about curly braces. So, and also about key value pairs, if you remember. So what I've done is, I've just created a simple dictionary here where I say my underscore dict is going to have a combination of key and value, that is male colon Ravi, female colon Sushma. So I've got these key value pairs stored across and I'm creating a dictionary here. So just by running this code, I am creating a new dictionary. Let me execute this and showcase what is there. So whatever I wanted to create, it has come out as a dictionary. Now you need to understand what are the keys and what are the values. You have dot keys as a function. So for any dictionary that you have created, dictionary name dot keys, if you use, you will be able to pull across the list of keys. So let me execute and show it to you what kind of keys that come out. Here we have two keys, male and female. So it has come out correctly. Now if you want to access the values of the dictionary, all I have to do is I just need to use values as a function, dot values for the dictionary name, and that can fetch me the values. So look at this, Ravi and Sushma are the two values and we are able to see that very clearly. In the same way, we can also grab values using keys. So how do we do that? If I just pass on the key as a value, as a parameter to the myDict function, I'd be able to get the corresponding values. Like for example here, the value for this male key is Ravi. So when I pass male as a key, as a parameter, I'm able to retrieve the value, corresponding value of it using this. Now is there a way that I can find out what are the different key values that are there? I can do that by using items function. So when I use dot items function, it returns a key value in the form of tuples. So we understood tuples earlier, if you remember. So it shows dict items male comma Ravi, female comma Sushma, and that's how the tuples are returned. So as a value in the dictionary, we can have a single value, a list, or even other dictionary that can be stored within a dictionary. So check this out. Category underscore lookup, the one that I'm creating with the help of curly braces, I'm able to showcase furniture colon 100, linen at colon 59, garden colon multiple values, then again kitchen colon multiple values. Now if you notice, interior colon 300 is itself a dictionary since you are finding it within the curly braces. Now despite that, you are storing it as a value for another key. Now when you execute this, you are creating a dictionary which carries multiple values. It carries a value, it carries a list, it carries another dictionary too. Now let's look up furniture. What is it returning? When I put furniture as a key and pass it across to this particular list, as I showed you earlier, it is retrieving the corresponding value. the corresponding value here is 1000. Same way, when I pass garden and then the 0 item, since we have multiple items here, it should ideally return 169 for me, which is right, because that's the first value. If I say garden and then 1, it will return 250. If I say garden and 2, it will return 500. This is how the dictionary values, you pass key and then you retrieve value by doing this. Same way, if I use balcony and interior, remember balcony is a key and the value is corresponding dictionary, because here we have a dictionary that is already available. So you are passing the key for the dictionary which is stored in the dictionary. So when you pass 2 keys, it's more like a nested format. So it is going to retrieve the corresponding value 300 there. So I hope you are able to understand how this whole dictionary is set up. Now let me also show you how you can add key value to dictionary. So I am here adding some categories or some key and assign a value to it. So take this one. I am just adding vegetable as a key and I am assigning the value 1500 to it, and I am creating a key value pair here by doing this. Let me execute and show it to you how this new item is getting added to the dictionary. Now if you look at it, apart from the balcony and the interior, which was the last value in the dictionary, now we have got vegetables 1500 also added to this dictionary. A simple action which has helped me to add a key value pair to the dictionary here. Good. Now you have understood what is a dictionary, how is it different from a list, how dictionary has key value pairs, and how you can retrieve values, how you can add values to the dictionary. You have understood all these aspects in this particular topic. Now, as I always request, you do your hands-on separately, practice more so that you understand this concept of dictionary in a better way. See you again in the next topic, where we will discuss more about tuples and so on. Thank you. Welcome back. In the last topic, we discussed about dictionary and how we can create a dictionary and how we can add items to the dictionary. In the same way, in this particular topic, we are going to discuss about tuples. So what is a tuple? We discussed this concept long time back. Tuple is going to help us to get some items stored in a similar format like list. Let's do some hands-on to understand tuples better. So I'm going to create a new tuple. So I'm just going to use the normal brackets. Like when I say my underscore tuple and 1, 2, 3, 4, 5, I'm assigning these values just like a list. I'm just assigning it to my underscore tuple. By doing this, I can create a tuple. So creation of tuple is very similar to dictionary or list. Just that the way the braces are used are different. Now when I check the type of my tuple, you can understand that it's coming out as tuple. Python recognizes that you have created a tuple. Now the length function, len, can be used to identify the number of items that you have in a tuple. So by executing this, you can see the value 5 because we have stored 5 elements in a tuple. But remember, tuple has a feature. We cannot mutate a tuple element or add any new elements in a tuple. So when you say what is the value that is stored across in 0, it's going to change. Like for example, my tuple of 0 actually already has a value, isn't it? 1, 2, 3, 4, 5 when we stored it. My tuple of 0, 0 index, only value carries 1. Here, when we assign 100 to it, we are trying to override that 1 with 100. Now you see the error? Tuple object does not support item assignment. So clearly compiler tells us that, look, this is a tuple. you cannot update any values that are already created. So immutable records, if you remember the property, that is something which is very important for tuple. So we cannot mutate a tuple element. I hope you have understood this. This is pretty different from the other data structures that we have studied so far. Now, can I create tuple with multiple objects? Yes, you can do that. So I can create a mixed tuple where I say 1, 4, new, bridge, different values. You can see integer, you can see string, you can see float. You can put all of them in my mixed tuple. You can do that. When I execute this, I can see that I've just added all these values to the tuple. Just that if I want to change from new to old, I wouldn't be able to do that because the immutability is the feature of tuple. Now when I check these values, mixed tuple of 0 will return 1 because that's the first value. Mixed tuple of -1, do you remember? It is reverse indexing. So it is giving me 998.7. Just to take you back to the old session, when you do reverse indexing, it starts with -1 and not 0. But when you're going forward with the normal indexing, it starts with 0. That's the difference. 0 versus -1. So mixed tuple -1 gives you the value of 998.7 easily. Good. You have understood the basics of tuples now. Now can we play around and execute and do certain functions with slicing and indexing? Can we do it on tuples? Now take mixed tuple 2. You know what the value is. The value is going to be new, as you know, because we know this is the value that we have stored across. Now can I access multiple objects using colon? That is, I've just retrieved a particular value by giving the index value. If I want to retrieve multiple objects, how can I do that? You know this technique, we already discussed it earlier. Colon can be a one which can explain the range, starting value and ending value. If you don't give the starting value and you just give the ending value, anything from the start till that ending point is going to be coming out. If you don't precisely mention the ending point, any starting point that you have mentioned, from that till the end of that particular data structure, you're going to retrieve all the items. Now let's execute this. Mixed tuple :4. So it's going to return all the first 4 values, 0, 1, 2, 3, which are stored in these indices. It's going to come out. So 1, 4, new and the bridge are seen as the output of this particular tuple. Good. Now you have understood how tuple works, what tuple can do for you. Now I have a question for you. Can you find out an answer? Can you tell me what kind of data can be stored in tuple? And when would you prefer a tuple over other data structures? This is an important aspect for you. So with this, you have understood how tuples work and what are the different operations that you can perform on tuple. Now I have a question for you. Can you find out where tuple can be used? Especially when tuple has this beautiful feature of immutability. Once you store it, you cannot change it. When do you think this property can help you out? What kind of data points can be stored across, and in what context this tuple will make more sense compared to other data structures? Think about it and share it across. Thank you. See you again in the next topic where we will learn about sets. See you in the next topic. Thank you. In the last few hands-on sessions, we tried different aspects of list, dictionary, tuples. Now it is important for us to understand the last one, sets. So what is a set? So set is unordered collection of unique elements. Now can we create few in our Jupyter notebook and see how this works? So how do you create a set? Just like you have the tuple, dictionary and the list, same way we have a set function. All you have to do is you need to put across the brackets and just pass these values to it. A set is created. So my underscore set equal to set of the values. Now when I execute this, the new set is created in the name of my underscore set. Now set takes only single representation of each value. So let me show how this outcome comes in. When I print my underscore set, you can see that it is just the unique elements from the list is getting added to the set. Even though I have around 10 to 12 values that have been passed across to the set, it is not storing all the values in the set. It has just taken only the unique elements and removed the duplicates. It has only taken the unique elements like 2, 4, 5, 9 and 10 and removed all other duplicates. Where do you think this particular concept can be used? Think about it. Do you see any specific applications for sets? Something for you to ponder. Now, how do you add a new element in a set? You have understood that set doesn't carry any duplicate values. Now, having understood that, let's play around and create some new elements in a set. How do you do that? My underscore set dot add. Add is the function that we use to keep adding elements to the list. When I add 50 here, it's going to add it to my underscore set. And when I print it, you will see that apart from 2, 4, 5, 9 and 10, I've also added 50 to the list, to the set that I've created. So I've got 6 elements in the new set that I've created. Now, a simple homework for you. Can you try adding the same 50 again to this particular set? You know that the duplicate is not allowed, right? Now try it out and see what comes out as outcome. Something for you to learn. What kind of operations you can do on set? So I've got 2 new sets containing integer values, set A and set B. As you can see, all unique values. So 2 sets are going to be created. Now I can find out the intersection between the 2 sets. Since they are unique values, I can find out what kind of intersection that exists between 2 sets. That is a common points, common values that exist across these 2 sets. So what is the property? What is the function that I'm going to use? I'm going to use the intersection function. So set underscore A dot intersection, and I'm passing set underscore B as a parameter to it. Now when I execute, how do you think the outcome will be? You can notice it very clearly. You have very few common elements. Even though the total number of elements across A and B are more, there are only 5 elements which are common across set A and set B. That is 2, 4, 6, 8 and 10 are the common elements, and that's the outcome that you get when you try intersection. The same way, I can try union. Union means I'm going to find the total number of unique elements that are there by combining both the sets. What is the function I'll use? I'll use dot union. So set underscore A dot union, and I'm passing set underscore B as a parameter. Let's execute and see. Now do you see all the unique values put across here? And this 2, 4, 6, 8, 10, which came as the intersection outcome, is represented only once in this union. So even if it is repeated twice or thrice, it's not going to come out. It's only the common unique values or the total unique values that are available in both these sets. That's what is going to come out as a result here. Good. With that, you have understood how sets work. So in the last few minutes, you have understood the operations of sets. You have understood the union, the intersection, and how sets can be created. Again, I would ask you to answer this question for me. Where do you think sets can be used? Now you have understood 4 different data structures: tuples, list. Okay, in the last few minutes, you have understood the different operations of sets. Now I want you to answer a simple question for me in the comment section. You have understood 4 different types of data structures: list, tuples, dictionaries, and sets. When do you use what? In what context you are going to use these data structures? You have learned the properties of these data structures. So those properties are going to help you to understand where it can be applied. Can you think about it and can you put it in the comment box? I'd love to check that. Thank you. See you in the next section. Welcome back. In the last section, we discussed about data structures. You got an overview of what data structures is all about, the different types of data structures that we can use in Python. In this section, we are going to learn more about functions. Let me give you an overview of this particular section. What are we going to discuss about functions? Basically, in this section, you are going to understand about functions and how it is being used across in Python. You'll also learn the types of functions that are available in Python for the programmers to develop. You'll also understand the structure of functions. How is it structured, the syntax of it, how do you use it? Then we'll also talk about the different types of functions that are available, including the anonymous function called as lambda. Then we'll look at some of the popular functions like map, filter as part of this module. And finally, let's do everything hands-on in Python. Are you excited to learn this functions module? Let's get to the next topic and start learning about functions. See you in the next topic. Thank you. Welcome back. In this particular topic, we are going to learn about functions. So what is a function? It is a block of organized reusable code. As a programmer, it is important for us to write lines of code and execute the programming logic. But is it always like we need to rewrite everything from the scratch? You would have learned about libraries. Libraries is one form where we are able to import the code which has been written already. So instead of reinventing the wheel, we are able to bring those reusable components and apply it. Like that, one of the best coding practices that we can follow when we are writing programming language like Python is you can have functions defined. So functions are a block of organized reusable code which can be used to execute the same thing over and over again. That is, some piece of code, if you believe that it's going to be executed continuously again and again, you can write it as a function and you can call that function passing some parameters, execute the lines of code with those parameters and get the response back. Why do we need functions? What are the benefits of functions? The first and foremost benefit, as you would have understood right, is it removes duplication of the code. Instead of writing that same lines of code again and again, I've written it once and I'm triggering that code again and again by calling that function. That's the biggest advantage. The second important advantage is you can decompose the complex problems into smaller pieces and simpler pieces so that you're able to carve them out as functions, and by triggering those functions, you're able to execute that code. Are you able to connect this concept with the hoops concept? Python is a hoops programming language, isn't it? It follows the hoops basic concepts. So what you're trying to do is you're trying to abstract and encapsulate a piece of code in the form of a function. Thereby, you're reducing the complexity and you're breaking them into smaller and simpler code. So that's the second biggest benefit of functions. The third one is clarity. When somebody goes through the lines of code, maintenance is something which is important, isn't it? When somebody goes through the lines of code, when you're writing functions, it is easier for them to refer, it is easier for them to navigate and find out what is happening inside those functions. So that's the third biggest advantage. And last but not least, when you have written the code, reusability is something which is very, very important. Any good programmer is judged by the kind of comments and by the kind of reusable code that the programmer has created. So functions really help you out from that point of view. So that's the biggest advantage of functions. Now I'll give you a simple example of what functions is all about. Let's say that you want to convert a Celsius temperature to Fahrenheit. So you are getting some code you're getting a huge table whereby the data is available in the form of Celsius. You want to convert that Celsius to Fahrenheit. So every line of code you are going to pass it across to this program or a function, and you are going to get that output in the form of Fahrenheit. So input is Celsius, output is Fahrenheit. Sounds very simple, isn't it? Now if I want to do this, will I do it for every row? Am I going to write the same code again and again? It doesn't make sense, isn't it? The common sense tells us that we just need to write a simple function. A function to convert Celsius to Fahrenheit, whereby you say that you accept something as an input, as you can see, like Celsius equal to float, because it can be in numbers like decimals. So I'm defining it as a float data type. If you're able to reconnect it with the previous modules and the sections that we covered. So Celsius equal to float, and you're accepting input like enter temperature in Celsius, like the data can come in any form. You're asking the data to come in Celsius format. And then you're converting the Celsius to Fahrenheit. You know the formula for conversion. So Fahrenheit is equal to Celsius into 9 divided by 5 plus 32. Now this is the formula that you apply to convert Celsius to Fahrenheit. Now are you going to write that formula for every line of code? No. You create a function, you put it across in a function, you pass input parameters, and you get output in the form of Fahrenheit. That's exactly what we have done. So you have created a function, you are passing the input in Celsius, you are executing this piece of code, the logic that has been given for converting Celsius to Fahrenheit, and then you are getting the output. And that output is getting printed. And that's exactly what you are seeing on the screen as an example of a function. So functions are one of the biggest assets of Python, or for any other programming language, I would say. So you should know how to use functions. You should know when to create functions. So anything reusable, anything that you are going to execute again and again, it is important for you to create functions and then carve it out as a separate piece of code, and you just invoke it by passing in the right parameters, and you get the necessary output. So remember, functions are important, and a good programmer creates reusable components of code like functions always. In the next topic, we will understand the different types of functions that are there. So I'll see you in the next topic and explain to you what those types are. Thank you. Welcome back. In the last topic, we discussed about functions, what functions are, and I told you that functions are reusable components of code that you create, so that you need not write the code again and again. You are going to pass something as an input and get something as an output, and you define the logic within that function. The logic is written as a piece of code within the function for which input and the output are clearly defined. Now it is time for us to understand the types of functions. Broadly speaking, there are two types of functions. One is a built-in function. The second one is the user-defined function. Built-in function, as the name indicates, the programming language itself has certain functions that have been defined internally or inbuilt, which is available for any programmer to use. Like for example, the popular one that we use, print, is an example of a function. Any parameter that you pass in as an input, you are going to print that. So there is a code written for print function which is helping you to print that parameter that has been passed across. So that's a simple inbuilt function. To give you some more examples, minimum, maximum, average, all these are some of the examples of built-in functions. Just like how you do it in Excel sheet. In Excel, the moment you put equal to in a cell, you see a set of functions that are available for you. Those are inbuilt functions that are available in Excel. Likewise, you have all these functions available in Python also. As I told you, minimum, maximum, average, there are so many functions that are available which you can reuse. But what is important for you is you need to understand the syntax. You need to know what is the parameter that you need to send as an input and what will be the output that you are going to get. Of course, you need not memorize that. Don't be worried about it. Over a period of time, with experience, you'll be able to understand what are those functions, what are those inputs, and what is the output that you're going to get from those functions. But it is important for you to understand that. That is very clear. So this is built-in function. Now let's understand the second type of functions, that is user-defined functions. The simplest example for user-defined function is the one that I told you in the last topic, Celsius to Fahrenheit converter. You may not find this as a built-in function in Python because not everyone uses this, isn't it? But if it is needed for me, I'll create a function, what I call it as user-defined function, where I'll define the programming logic for this particular conversion, Celsius to Fahrenheit, within a function, where I will define, like, this is the name of the function, this is the input parameter, and this is the output that you may get by passing these parameters. So this is called user-defined function. You can create functions for different purposes, like as simple as Celsius to Fahrenheit, kilometer to miles, any kind of conversions, or as complex as book a train ticket, book a flight ticket, send these details as input, write a huge programming logic whereby every time you want to book a ticket, you can send these details like name, age, preferences and everything, and accordingly the ticket is booked and automatically the seat number and everything is shared across. So functions can vary from simple to the complex one depending on the kind of problem that you're trying to solve. So what did we learn today? We learned two types of functions. The simple built-in functions which are available in Python, and the complex user-defined functions where you can define functions based on your needs, based on your business needs. I hope you understood the difference between the two. Check, explore, understand how these functions work. We'll learn more about functions in the upcoming topics. Thank you. Welcome back. In the last topic, we understood how different operations can be performed on a list. Now in this particular topic, we are going to learn about how the Python list can be transformed into multiple other data structures. So let me get back to the notebook. I hope you have the same notebook ready. So I am converting a string to a list. How can I do that? So I'm just creating a simple string here. Welcome to this course. So when I create this, I am carrying the string welcome to this course assigned to text, and I'm just executing it. When I execute this, the text is created. Now I am converting that list. Actually, I'm splitting the text, what I've got, and then I'm assigning it to the list. Let me execute this and show it across what happens. So welcome to this course. That's what has been split up. So I had 4 different words, array of different words coming out in the form of a string. Now this particular string of text, txt, I'm just splitting them. The moment I say split, automatically bases the blank spaces, it has been split across. So it knows that there are 4 words, welcome to this course. Now all these 4 words are added as elements to the list. So that's what has happened. That's why when you print the text underscore list, you're able to get this outcome. Now let me do the same thing. I'm creating a new text and I'm saying that, hi, welcome. Today we will learn about list. Let me execute that. Now the new text is created. Now let me split them with a specific parameter or a delimiter, that is full stop. The period is something that I'm using here to delimit, to split the complete words. Can you make a guess? If I split this with a period, what do you think would be stored across in this text underscore list? Can you tell me how many elements will be there? Yes, you guessed it right. We had 3 different sentences here. Hi, welcome. Today we will learn about list. All the 3 are stored as 3 different elements, considering we have used period as the delimiter. So this is how we convert a string to a list. Every character or every word, or based on the delimiter, every sentence can also be added as an element to the list and a new list can be created. Now, can we do the reverse thing? Can I convert a list back to a string? Let's understand how. Let me go back to the last text list that I created. That is, I welcome. Today we will learn about list, the three elements that are already there in this list. Now let me check the type. It should come out as list, isn't it? Because this is a new type. Now what I'm going to do is I'm going to use a delimiter, and then I'm going to say that just like I use a split on the other side, I'm going to use join on this side. So how am I going to join it? With a space. That's why we see quotes here. Let me execute this, and I'm storing it in alpha. Now let me print alpha and see what is there. Good. We have got all the three elements added now, and the new list has been created just with the space added in between, isn't it? This is exactly what we expected. Now check out the type of alpha. So what is your expectation? Will it be list or will it be a string? It will be a string. So you have taken all the elements and you have put it across in one particular string. Same way, let's try one more example. List carries 5 different or 6 different alphabets, A, B, C, D, E, F. Now I'm using hashtag and then I'm using join. Can you guess what the answer would be? Let's see whether your answer is right. As you saw in the previous one, we used a space. Here we have used an hashtag. So you're getting this response: A hash, B hash, C hash, D hash, E hash, and F hash. This is how the operations can be performed. Like either you can convert from a string to a list, or from list to a string. Now let's also look at how to convert list to a dictionary. If you remember, list is something which is coming out with the square brackets. But when you talk about dictionary, we talk about slightly a different format, isn't it? Let's see what that format is. So I'm defining a simple list, name underscore list. I've taken 5 different names. I've just created a new list. And I'm assigning marks. I'm creating a new marks for each one of them. So 80, 72, 87, 92, 16. This is another new list that has been created. Now I'm going to create dictionary. If you remember right, when we discussed this topic earlier, I told you dictionary is a combination of a key and a value. You have a key value pair that is stored in a particular data structure. Now here I am defining that what is the key and what is the value and how it is going to be stored in one place. So my underscore dict is the dictionary name, and I'm using dictionary function dict, and I'm saying zip name underscore list and marks underscore list. This is going to help me to create a dictionary. Now the dictionary is created. Let me print my dictionary and see what is there. You can see this very clearly. Uday colon 80, Suraj colon 72, Raju colon 87, and this is what is stored in the simple dictionary. Now check the type of my dictionary. It is very clear. It is dict. Now let's convert a list to a tuple. You have understood list and how it can be converted to a dictionary. Now let's understand how the list can be converted to a tuple, which is another data structure. Tuple function can be used to convert a list into a tuple, just like the dict function, which was used to convert it to a dictionary. So I've taken my tuple, and then tuple of my list has been assigned to that. So tuple function is used across, and I have passed list as a variable into it. Let me check out my tuple and what is stored there. So it has got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember my list? Earlier we had created with the help of range 1 to 10. That's exactly what this is. Now let's check out the type of my list. Type of my list is list. Very clear. And type of my tuple is tuple. So we're able to convert the list to a tuple very clearly here. Now in the same way, can I convert the list to another data structure, set, in Python? Just like you had dict for dictionary, then tuple for tuple, now we have set as a function to convert a list to a set. So same way, I have my set which is created as a new set, and I'm passing my list to a set function which is going to help me to create a new my set. Now when I print this my set, I can see that the values are stored in the same way, but I hope you're able to see the difference. Now this comes in parentheses, the curly braces, if you remember. Now this is different from the tuple where you saw it in direct braces. So you understand the difference. Now when you check the type of my set, set is the answer. So this is how you can convert multiple lists into different data structures. Now I want you to try all these things, explore these functions better, try creating new lists and convert them to different data structures. While in the next topic, I'm going to talk about how you can play around with the values in the list. We will cover that in the next topic. See you in the next topic. Thank you.